Okay, guys, let us continue our session. So we started with today with the session 1. So let me continue with the day 2 session 2 actually. When today is day 2 session 2, and the time is 10:57 a.m. IST. Okay. Now, so in our previous discussion, I just stopped it here at this position where we said that okay, whenever any command is getting executed, first the shell has to search where that command is coming from. So it is coming from particular path. So with the help of a path, environment variable, what the shell will do, shell will try to search for that command in that particular path. So if you go and if you execute the command echo $path, echo $path. So this is very important. As I said earlier, this is one of the important shell variable, which we'll be discussing in some time after some time. So with the help of this path environment variable, the shell is going to search whether the date command is there in under this path. No, the date command is not there in the path. Whether this command is there in this path. No, this is not there. Yeah, it is there in this path. It will try to get into that path and it will load the date command and it will execute it. It'll load that command into the memory, as I said, and execute it. But do you think that the bash shell itself will execute it? No, bash is a main shell, or it is a main shell. Now, whenever you are executing any task, the shell will never execute by itself. Okay, if it is never executed by itself, or if it doesn't execute, then who is going to execute it? So what the bash intern does, it is going to create a subshell, a small chota shell, or the child shell it creates. So whenever a task is given to the bash by the user, so CentOS user, he will tell to the bash that, hey, please execute the date command, or please execute the ls command, like that. Please execute the ls command, or please execute date command, or please execute some application program. You are giving a task to the shell, right? You're telling the task, or you're telling to the shell to execute some task, right? So here what happened, the shell itself will never involve in doing it actually. It will always create one small shell actually. How it creates a small shell? What happened internally, there is a API, application program interface by name fork. So what the bash shell will do, it will try to call a fork API, a fork system call, or a fork API, which is FORK, fork API. So this fork is one of the APIs, sir. Don't worry about that much. Just listen what I'm saying. Fork is one of the API. It is an API. So fork is basically the fork will always create a new process. A new process. So with the help of this fork, what this bash shell will do, this bash shell will try to create a new process. And this new process, but this is also a bash process only, but this is a child process. It's a child process, child process. Okay, so it has created a child process with help of a fork system call. Very good. So now, so Rajesh, it means that if I'm running hundreds application, do you think that bash is going to create 100 different child shells to execute it? Yes, it always creates 100 different child processes to execute all 100 different tasks. So it means that Rajesh, whatever the command I'm executing, so Rajesh, you are saying that Rajesh, if I go here I'm executing so far. See, if shell is creating one more subshell, yes. If shell is creating one more subshell, yes. If shell is creating one more subshell, yes. If shell is creating, see, for every execution of every command, right, the main bash shell is actually creating a sub process, or it's creating a subshell or a child shell. Always, always. You can even prove it also how it is creating. Okay, we'll prove it also. So what happened, right? Once it creates a subshell, a small shell or the chota shell or its own shell, right? It creates it. Now the main bash shell has to instruct to the child shell, right? Hey, you do this task. See, now for example, like we humans, right? So what we do, right? Basically, we say that actually, or I had a dream that I want to become a doctor actually. From the very child, now I was thinking, okay, I will become a doctor, but I couldn't become a doctor. I become an engineer. Suddenly, at some point of time, right, I thought that, okay, I should have become a doctor, man. But yet I couldn't become a doctor, I become an engineer. What to do? You cannot go back, right? Because your age is going on. You cannot go back to the college and sit and learn, right? I mean, you cannot do it. So what I will do, I will just say, okay, man, I'm the mature guy now. I've grown up now. Let me get married, right? Let me create some children. I can instruct my child to become a doctor, right? At least, right? So that's what you are instructing your child. Hey, you become a doctor. I'm instructing my daughter. Hey, you become a doctor. You become a pilot. Right? Delegating. You are delegating the responsibility. Say. So the bash shell has to delegate the responsibility to the child shell, right? So delegation of the responsibility of the work, saying that hey, that is happened through exec system call. Through help of a exec system call, like the main parent shell, the parent shell or the bash shell is delegating the instructions or the commands to be executed by the child shell. This is what it happens, sir. Exec is one of the API which will get called up actually. Exec is one API. So fork and exec, these are the two important API which always the bash process will call. So what happened, right? When the bash process calls a fork, a new child process will get created. Once the bash will call exec, it'll delegate the responsibility that, oh, okay, date is a command which a user want. Date is a command which user has to execute. It will tell to the child process that actually, hey, you execute this date command. So this child shell, right? This child shell will now take care of executing the date command. They'll take care of executing the date command. Now, once the child shell completes execution of it, now it returns back the value of the date command, okay, to the main bash process. So whatever it is, right, it will return, right? So what happened, right? Once the child exits, when the child exits means exit out. Exit out means killed. When the child exits, means after completing the task, it returns the value of the entire output of the date command. It returns the value to the bash shell or to the main shell. So that's what you could see that here the main shell is a bash shell, but it creates a subshell. So always there is a relation between a parent and a child, right? Child, once it completes, it cannot go to some other person and say that, hey father, see, I've completed my degree, no, right? Because he understands, oh, you are my true father, you are actual father. So the child will come to you only and tell that, okay, I've completed my degree, I've completed my MBBS, right? Whatever. So what happened, right? The child understand that to whom I have to return the value, to whom I have to return the value. So that how that understands means the child process will also maintain the PID of the bash shell. It means that when the child process is getting created during fork system call, the child process will get created, but the child process will also have information about who is my parent. How it keeps information about who is my parent? It keeps information of the PID of the main bash shell. That's how it happened when it is returning the value to the main bash shell. When it is exiting out, it understands to whom I have to return back the value. Because it has the PID of the main parent shell. Clear, sir? Till here?
Yes, sir.
Okay. This is all about, this is all. So now the question comes, okay, sir, sir, you are executing any commands. Does the bash shell is going to create a subset? Yes, sir. Sir, if you're executing any application or anything you're doing, sir, does a bash shell will create a subset? Yes, sir. Okay. What then if bash itself is doing, if bash is not doing anything, then what bash is doing? Bash is managing everything, sir. It manages all the processes running under it, right? It manages the communication between that particular user to the kernel, okay? And there are many things are the where shell also will do itself. It is not like that. I know everything that Pujari will delegate the responsibility to the god. It's not like that. Like, there are many things are the where Pujari himself will do, right? Or the priest himself will do. It's not like every time he's depend upon the god only, right? So there are many tasks are there where the bash itself will do. It will not give the responsibility to the kernel actually. There are many occasions are there like that. There are many places are there where the basher itself will do itself. For example, if I want to a little bit tell you more, for example, yeah, if I want to tell you one more example, like for example, whenever you are executing any command, shell will also search or it will also check whether this shell or whether this command is a built-in or a non-built-in. Oh, what is this built-in, non-built-in? Yes, whenever any commands which are there in a file system are nothing but or in some particular path, whenever any commands are there in this particular path, or it means that it is there in some file system, or it is there in this path, all those commands are non-built-in commands. Any commands which are there within the shell itself, the shell will maintain a command. Those are called built-in commands. Like for example, I'm doing a cd command. I have not yet come to cd. Cd means change the directory. This is one of the command. What is this command? A cd command. Cd is a shell built-in command. So how to check whether any command is a built-in, non-built-in, built-in or a non-built-in? There's a type command. If I say type cd, see, it is a shell built-in command. Okay, beautiful. Whenever if I say type date, see, it is hashed command. It is not a built-in command. Or if I say type ls, oh, it is an alias command. Type if config, it is a hashed command. Type mount, see, it is there in this path. So type command, if config, date command, ls, these are all non-built-in commands. Whenever the shell want to execute any kind of commands which are non-built-in commands, always it will follow this process of creating a bash child shell and doing it. Whenever the shell is executing the built-in commands, right, like cd command or dot command or many other commands are there, right? Then what happens that the shell is going to, it will not create any subshell. It will execute itself. So if any crazy person, if he asks an interview, right, shell will create a subshell. Yes, sir, everything. What are the things? What shell can execute by itself? It shouldn't create any subshell, or it should do by itself. Sir, always shell will execute all kind of commands which are built-in commands. Okay, all built-in commands will be executed by the shell itself. It will never create a subshell. So again, if you ask me why is like that, I think for explaining that thing, it will be too difficult. It's not like too difficult. I feel like you will not be able to understand why that is all about. But they've categorized this into two categories. Commands are built-in and non-built-in. And if you see the commands, 99%, not 99, 100%, all the commands, whatever we get in a system, all are non-built-in commands only. They never reside within a shell. They are all are outside shell. Some 20 or 25 commands are there, which along with the regular expressions also, those are part of the shell itself. Shell itself will execute those commands. For example, there's a command known as expr. If I say type expr, see, oh, expr, it was a built-in command, but they have removed it now. Type dot, see, it's a built-in command. Type double dot, it is there is no command within double dot, it's only dot. So what I'm saying means there are around 20 commands are there, which are all the non-built-in command, built-in commands. Clear, sir?
Can we see in terminal for this creating this subshell?
Yes, we'll show you, sir. Because see what happened, sir, the execution is so faster that you will not be able to see when it created, when it get exit out. Because this execution, this ls command is a very simple task actually, right? For example, right? For example, so what is a command to check what is a PID of your bash shell itself? If I want to check it, there is a command known as echo double dollar. Echo double dollar will give you the, or will display the, what guys, will display the PID of the shell itself. Or else there is one more variable known as echo dollar PID. This is also same. So if you execute echo dollar PID, okay, it's not there. So, oh, sorry. PID. Oh, it is not there. They removed it, sir. Echo dollar PID was there. Actually, it will display the PID as well, but I think they have removed that.
Bash PID.
Yes. Okay, that they have removed it. Or else you can execute the PS command. PS command will give you the 1154. This is a PID of your bash shell itself. Right? Now, for example, if I say, see, now please understand now, this is 1154 is the PID of your bash shell. Now, suppose I'm creating a process which is continuously getting executed. It will never come out at all. It is continuously getting executed. It is continuously, yeah, bash PID, yes, bash PID, right? Bash PID is there. Yeah, sorry. Yeah.
Yes,
No,
it's
earlier
there.
it was PID. Yeah, earlier it was PID. Now they have changed it to. They will be doing some enhancement changes and all. Yes, correct. Thank you, Aram. So 1154 is a PID of the shell. Now, for example, if I say yes, hello, yes is a command which will recursively run this hello on the terminal. See, unless and until you kill this process, we keep running it. Suppose if I go here to the other terminal. So if I execute a command, this is the CentOS, right? Let me go to the CentOS terminal itself. This is CentOS terminal. If I say ps-ef pipe it to grep, okay? I pipe it to grep -I, yes, hello. Okay, or else ps-ax. Can you see? Yes, hello is running. It is having a PID 1518. So even though that process is running here in a terminal, what the shell is doing, how shell is running it? Shell is not running this. Shell is creating a subshell. Shell, the shell PID is 1154. If you come here, if you go at the top, see, this is the PID of the bash shell is 1154. But this bash shell is not running this, hello, yes, hello. It is actually run by one more new process known as the 1584. 1518 actually. So this is a new PID which has been allocated to a newly created process. It means that this bash shell has created a subshell, and this 1518 is a subshell. It's a subshell. Clear, sir? Now, if I go back here and if I do a Control C, so I have to press always whenever I want to kill a process which is occupying the terminal, whenever I want to exit out from this, I have to just press Control C. When I do a Control C, it is going to kill that process. So again, you come out here, come back here. Again, you execute the ps-ax command. Now you could see that 1518 has gone now. It is not there.
Okay. Thank you, Rajesh bhai.
Always, it is always like that.
One more small question, Rajesh bhai. Hello.
1 second, guys. 1 second. 1 second. Sorry, guys. My daughter had come actually. That's all. Fine. Yeah, go ahead. Yeah, please ask me.
Yeah. In one terminal, we are executing the command. In duplicate terminal, we are checking this process IDs, no?
Correct. Right. You're right.
Then it will give that executing commands also in different terminal.
In the different terminal, you can check all the PIDs which are running in a system, because this is the CentOS user, right?
Yeah,
Here,
but it is a different terminal, no? I mean duplicate terminal,
it's a
no?
terminal. See, but the username is same, no? But the system is same, machine is same, no? You can
Yeah.
log in as n number of CentOS as a user in n number of n number of different machines. Suppose here I'm logging in. Suppose I give you the username, the password, and I give the IP address of the machine. You can log in, right? From your home, some other
Yeah.
person. All are logging. All are getting different terminals, but they all are communicating with the same kernel only, right? It's not like that you are getting different kernel. No, only one kernel, only one operating system is there, right?
Yeah. Right.
Yeah, like this. So every user will get a different shell, and the different shell is but the PI. So different shell is going to get, and each and every different shell has a different PID. But because as a system, there is some set of processes which are running. That is common, right? So that's what when you're executing the ps-ax command, you'll be able to say that what are the processes that are running in the system that will get displayed, right?
Actually, this was me occupied this in duplicate terminal and if you history, you can see the previous experience.
Come again, sorry.
Suppose if in duplicate terminal, if we pick history now, then we can see the previous executed commands in main terminal what you executed, right? Those commands will be available.
Very good question, sir. Very good question. Now, what happened now, sir? Every terminal, whenever you log into the system, you will get a unique terminal and you will get a shell also, correct? But whenever you are executing any commands, that command will be pertaining to that terminal or pertaining to that session. You cannot see. Suppose here you are logged in and you are executing command. This user cannot see what are the commands you have executed, because it will maintain this terminal will maintain its own history of commands. It will maintain its own history of commands. Later what happened, right? Once you exit out from this, all these commands what you executed, it will be copied to one fixed file or one permanent file. So if this user want to see what are all the commands which has been executed by the system, he can go to that particular file and he can see it. There he can even see that, okay, whatever the other users who has executed, all the commands can be seen. But when the session is up and running, when the terminal is up and running, whatever the command is been executed, right, that will be maintained by the local memory only. So here also a user who has logged in, right? He's a CentOS user. He will be running many commands. So here, this user will be executing ls command, date command, and this user who is a CentOS user, he will be running some other commands. Like for example, he will be running some ifconfig command or fdisk command. This user or this terminal, he cannot understand like which are the, it doesn't know that which commands this in this terminal it is running, because this all these commands what is getting executed, right? This will be there in the buffer memory. Yeah, but once you exit out from the shell, what happened, right? All these commands which this particular user or this particular session was executing, right? That will get copied to one permanent file. What is that file? I will tell you. That file name is bash_history file. In that file, if this user sees, right, he can see all the commands what has been executed by various different users. Here, CentOS is user, but Rajesh is logged in, but it is CentOS user. Here, Kiran has logged in. It's a CentOS only. Kiran might be executing some commands. Rajesh might be executing commands. Those will be initially, it will be there in a memory only. Clear, sir? Once these commands are getting executed, completed, and once the shell is getting executed, or once you are killing the terminal, all this command will be copied to a permanent file, and the file name is bash_history. If you go here, I'm telling you everything now only that it is, but it is like it might confuse you. See, bash_history. This is a file where all the commands will be copied at the end. After, so suppose if I say exit, exit out, immediately when I say exit out, right, what are the commands is executed right by the cell that will get copied to .bash_history file. So guys, there are some confusion might happen now. I do understand you're asking a very valid question, but if I answer for every question, so maybe sometime what happen, other participants might get confused. What is this, sir? You're telling so many things we're not able to understand. So I will clarify everything, because when I come to the shell features and everything, no, I need to cover all these things, sir. There you'll get to know everything.
Rajesh sir, one more question is there. As you said, there is shell create a subshell and it has a new child PID. So how we can check mapping the parent process ID with this particular new generated child ID? Is there any mapping we can visualize?
We can visualize, sir, actually, because we can visualize it. See, again, this is one of the very like important question, but this might confuse many people. Okay. For example, if I want to show you, like for example, what the system will do, no, the kernel will do. Okay. I'm telling you now only, but I will just tell you the half answer, not the complete answer. I will tell you the half answer, not the complete answer. It's Vaibhav, right?
Yes, sir.
Vaibhav, I will tell you half answer, because if I tell everything, it will get confused. Now, for example.
No worries, no, sir. We'll discuss later on.
Sure. No, okay. So I'll give a hint actually how you can check the mapping. Suppose you're running any process. Suppose you're running. See, what is the process of this? Process of this shell? 1351 is a PID of the shell, right? If you do a CD to the slash, enter, and say ls, can you see something as a proc file system? Yeah, proc is there. Okay. Rajesh, can I go to the proc? Yes, sir, I can go to the proc. Rajesh, can you see 1351? There is 1351, 1351, 135. Ah, it is there here. Oh, super. Get into that 1351. Through this, you can able to get the information about what are the different child processes which are been running, right? Which has been created by this process PID, right? That you can view it actually. Suppose, for example, here this is 1531 is running. So I think bash, right? Now I will say yes, hello. Yes, hello. It is running. Now come back to other terminal. Okay, and PSAX. Enter. Can you see yes, hello? Where is running? Yes, sir. It is running 1552. Sir, can I go to the proc directory? Yes, sir. Can I say 1552 ls? Can you say 1552 here? Ah, sir. Through this, there is a file is there. Through that, you'll be able to see is that who is the parent of that actually. 1552. Sorry. Here you'll get to know that who is my parent actually. And sir, and got it, guys. One more very important. Now you are asking, Rajesh, what is this file descriptor 1012? Can you see in the proc file system there is something FD, CD to the FD? Sorry, CD to the FD. Can you see 012? See? Can you see it? 012.
Yes,
what is
yes,
012? ls-l. See, it is a soft link to your terminals. Is it proved, sir? Is this?
Yes, sir, it's proved. Yeah, sir.
1 second, guys. Hello?
Yes, sir, it's proved, sir.
Yes, sorry, yeah. So now, if you go back to this diagram, which I said in the morning, Rajesh, how a user can communicate to the kernel, to the command, to the system call, to the proc file system. Beautiful. Sir, Rajesh, this proc this is what you are saying about all these things? Yes, sir. If you go to the cd slash enter and say ls, see, there's a proc file system is there. Rajesh, there is one more thing, or something called sys file system. Is any sys file system? Yeah, yes, sys is there. Okay, super. It means that user can actually, even the user can actually communicate the kernel with the proc system. Yes, sir. Can a user can communicate with the kernel with the sys file system? Yes, it is possible. How is it? These are all programming parts. So you need not to worry all this. But you could see that in our file system we have everything. What is this slash and all? I will be coming very soon now. In another 15 minutes, I will come with this also. Now the thing is that the stuff is that, sir, for every question in Linux, in whichever way or in whichever depth you want to understand, there is an answer for every question. You cannot say that no, there's no answer, nothing. You will get an answer for every question or for every doubt whenever you're learning. So that's the reason Linux has become so when it becomes an open source, right? People started learning in Linux in a very in detailed manner. Everything from the top level to up to the kernel level, how things happen, how exactly the flow goes, how the control goes, how the control switches from the user space to the kernel space. When a command is getting executed, how the kernel executes, everything, sir, you can actually understand. And there's a detailed information is given in many books, actually. In many books. If you want to get to that level of understanding, means you have a lot of books are there. Like, for example, you have a book known as Understanding the Linux Kernel by Daniel P. Bowett. Under the kernel development, Linux kernel development by Robert Love. Okay, the design of Unix operating system by Richard Stevens. The design of Unix operating system by Samuels. Like that, there are many hundreds of books are there. And I got an opportunity to read all these books actually. In fact, the Daniel P. Bowett, it's a very fat book. We call this that as a Linux Bible book. That is around 600 pages. I have almost read around 350 to 400 pages I've read. So that is a very, very beautiful book, but I would not recommend you all to read that book because that is not required for you. So understanding the Linux kernel by, see, it is already come by Daniel P. Bowett. This is a book, sir. This is a very good book, actually. This is a very older book. It's not at 200 pages. It's a for 2.6 kernel. Now we are having 6 kernel, 5.0 kernel. This has been enhanced like anything. See, this is what it is. Mapping address, processes, interruptions, exceptions, kernel synchronization, time memory measurements, process scheduling, process address space. So whatever I'm discussing here, now you could see that what I'm discussing here, every user, right, will get created. He will be running the user space. Every user space, right, will get a process address space, we say. A memory descriptor, a memory region, a memory will be given for each and every process. And something the system call, POSIX API system calls, signals, virtual file system, like this is how it is. So, but I would not recommend, guys, please don't read this book. But if you have an interest in learning or in understanding, you can definitely go through. These are all the guys who are very hardcore embedded developers or who are more into system level programming. Those guys read this book. Same thing, the Linux kernel development by Robert Love. See, the Linux kernel development by Robert Love. He's a guy. He is one of the member of the kernel.org. He's one of the team member within the kernel.org. He works close with with our Linux terminals actually, and he's one of the person who actually sign off the new kernel releases actually. He along with the Craig Crouch Hatchman actually. There's a guy by name. There is a book by name the Linux Nutshell by Craig something Crouch Hatchman.
Sir, no
Python.
voice.
Yes. Sir, now
Yeah, it's audible, sir.
Yes,
now.
yes.
Python in nutshell, sir, you need to read such kind of a book, sir. Any nutshell, any developer who want to learn Java, he'll always read Java in nutshell book, sir. Nutshell books, no, it will give an elaborate description about that entire thing. So always make a habit of reading any nutshell. So do you have for the bash shell scripting? Yes, it could be bash shell, shell, nutshell, PDF actually. You will get a PDF or you'll get the documents or everything. So you have to read those nutshell documents are actually. They will give they'll get an elaborative information about that particular shell actually. Clear? Some of the things I'm telling you out of box, which is not really required, right? But okay, that's fine. No voice. Vaibhav now?
Yes, sir, audible.
Yeah,
now.
Rudransh
Okay.
will share, sir. We'll share the PDFs. Don't worry. I will share the PDFs. Today I'll upload all the PDFs and documents for you all so that you can learn everything. You can start studying. Okay. Guys, I'm sorry. Some of the things I'm extra telling you all these things. It is not really required for us, but still, okay, whichever I feel important, I will tell. Okay. Okay. Fine. Now coming back here, what is other things that we have to learn? Any other things which is there? Okay. Let's go to the bash is going to create a child shell. Okay, and it exits out. Fine. I think I have covered everything, sir. So this much is enough for us. Okay. Now what is the other things next? Now what are we going to learn now? Now in Linux or in Unix, this Linux and Unix, it provides or it supports 6 different types of files actually. It supports 6 different types of files. Linux or Unix supports 6 types. What are those 6 different types of files? The first is that you can create a normal file or right. Windows, whenever you want to create any files, or what you will do, you will do a right click and you will go it here and you'll open to the new, and here you have a text box or something. This is a basic notepad.
Your voice is not clear, sir.
Your voice is
No,
not clear.
Rajesh.
It's leaking.
Now,
Now it's audible. Now it is.
can you hear me now?
Yes, we can hear you.
Thank you. So what I'm trying to tell here that you can create any normal file or a text file in Windows. This is not a normal notepad file or a text file. So this is a very, very basic file you can create. Similarly, in Linux, you can also create a basic file or a text file or we call it a white file. So how you can create text, different types of file or different different ways of creating a normal file or a white file or a normal file. You can create with the help of some commands, a touch command. You can create a file with the help of a cat command. You can even create a file with the help of echo command. You can even create a file with the help of a VI editor command or VI command. You can even create a file with the help of a head command, less command. Even you can create a file with the help of this greater sign command. So any one method can be used to create the file. For example, I want to create a normal file. I will go here. I'll do a Control C. Okay. So what I will do? So I will use a command using touch Alice. See, I'm creating a file by name Alice. So touch, you will create an empty file, or it's going to create a 0-byte file. So if somebody asks you what touch does, touch is going to create a file, but that is correct. But what exactly the touch will do? So touch will create an empty file, or it will create a 0-byte file. Okay, fine, good. Okay. Now, what are the other things are there? Cat is there, echo is there, lot of other commands are there. Even you have a greater command, like for example, greater command and say Bob and say enter and say ls. See, you have created a Bob file. Now, if I execute a file command, guys, basically it will tell you the file type, what type of file it is. If I say file and say Alice, say it's an empty file. Oh, okay, it means that it is an empty file or it's a normal file. Clear? So what does ls command do, guys? Ls command will display all the files and directories which are there in the present working directory. Okay. So what it'll do, it'll display all the files and directories which are in the present directory. So what is the command to display all the files and directories in Windows command line? Can anyone tell me what is the command in Windows?
dir.
Yes, good. dir is a command. Does the dir command is there here also? Let me check. Oh, dir command is also here also. You will find a dir command even in Linux also. Okay, fine. Then you will ask, sir, what is the difference between ls and dir? You will come to know shortly, because ls command will display all the files and directories. Even dir command will also display, but there's a small difference that ls will display all the files and directory even with the coloring effect. Coloring is in Linux, we have 7 different types of files are there. Sorry, 6 different types of file. Each and every different types of file, even it has a coloring also. It has a color. Like for example, the next type of file is a directory. Directory you can create with the help of a mkdir command. And always a directory will be in a blue color actually. See, if I do an mkdir and if I use I'll use the name Pratap. See, and say enter and say ls. Can you see? Pratap is in a blue color. So when I do an ls command even will also show you all the files. It will also show you the coloring effect also. It will also show the coloring effect also. Oh, it means that every type of file has a color. Yes. But Rajesh, what about the normal file? Sir, the normal file will always look like a black color only or in a white color. It's a normal file, right? It doesn't have anything, so it's a black color only. What are other types of files? Oh, it will be in a coloring. So Rajesh, can I execute the dir command? Let me see. So if I execute a dir command, it will display everything, but there is no coloring effect here. Oh, it means that everything looks like a normal file, but Pratap is not a normal file. It's a directory. Right? So hence you will say, Rajesh, even though the dir command is executing, I want to see or I want to display even the coloring even with the dir command also. So what I have to do, dir -fn color. See, now it will show in the coloring effect. Clear, sir? So now mkdir is going to create a directory. Can anyone tell me what is a directory? If you have any idea or knowledge, what is a directory, sir, in Linux or in Unix?
Folder.
Yes, it
Folder
is
The
a
directory is folder.
Yes, very good, sir. Why we have a folders?
The folder have property to folder files.
Few files. Inside
So
folder.
you say that, sir, we have a directory because we want to store everything inside a directory, and you can store multiple files, multiple different types of in a directory. We need a directory, right? So without a directory, can you create a file, sir?
Yes, it goes to this particular
Yes, sir.
user's home directory.
But where the user resides?
Under
Home.
In
home,
under
sir.
the user also the user also falls under, he is sitting under the directory only.
Correct.
It is not like that.
That is under
So,
home, sir.
yeah. Now, you know what happens, sir? Your whole Windows operating system, it is there in your C drive. The C drive itself is a drive, or itself is a directory, or itself is a folder. Everything is a folder, sir. There's nothing like a file cannot reside without a directory or without a folder. A file always reside inside a directory only. A directory has to be there. So, Rajesh, it means that when the operating system was created, when it was designed, does it research everything in a folder or directory? Yes, sir. It is always decided to be in a directory only. Okay. Or it means that everything resides in a directory. Yes. The directory has to be there. Yes. Without a directory, you cannot work with the operating system, sir. Everything, all files and directories, everything, important files, everything will be there in some directory, and that directory will be part of some other directory, and that directory will be part. It is a recursive, it's a infinite recursive. It means that you cannot say that a file resides alone without any directory. No, you cannot say like that. This is a very, very fundamental concept I'm saying, sir. Very, very fundamental concept. It means that the whole file system, the whole operating system, or the whole kernel, it works because of the directory only. Without a directory, it cannot work at all. Very fundamental, I'm saying. Okay. But what happened, whatever I am saying, some of you might not appreciate it. Some of you think, okay, something is saying, okay, something in a folder. But if you are a system programmer, right, you will be able to appreciate this sentence, what I am saying. So people understand in a very in detail manner about why exactly this folder is. If I start explaining out more about the folder structure, right, your mind will blow up. You'll say, what is this? So many things are in the folder only. So there is something as a D entry. You might have never heard. There is something known as a inode structure entry within a folder. You will never know all these things because it is very difficult, very complex to understand. Right? Like for example, I'm just telling you, I will not get into more detail. See, could see that? See, D entry in Linux. See, what is super block? I know D entry and a file block. See, we'll get it. Like for example, like inode structure entry. See, this is an inode data description. See, this is how the he's saying, sir, how exactly the folder look like. Inside the folder, what are the things are there? See, indirect, direct, indirect. These are all the pointers actually.
Rajesh sir, your voice is not there.
Can you hear me?
Yes, no,
Okay.
but your voice is breaking.
So now also the voice is
Yes, yes, your voice is breaking.
Breaking, sir. Since last 20 seconds. Oh, yeah.
Yeah. So now?
Yes, sir.
Thank you. Okay, fine. Okay. So now, so the first type is a normal file, second is a directory. You can create a directory with the help of mkdir command. The same command is also used in Windows operating system also, right? You can create a directory, right? So now, one interesting thing, and very interesting thing is that when you create a directory, when I create a directory by name Pratap, it has created a directory and this will show in a blue color. When I do an ls command, it will show even in blue color. Blue color represents that it is a directory. But how to verify whether it's a directory or not? You can run a file command, file space Pratap. See, it shows that it is a directory. So what is the file command will do? File command will tell you the type of file. File command will tell you about what type of file it is. Okay. Okay, what is the third point? Third important files. This is very important. It's an interview question. They'll ask you about what is a hard link. In many interviews, they'll ask you. Third type of file is hard link. Fourth type of the file is soft link, or we call it as a symbolic link. Sometimes they call it a symbolic link. Soft link file, hard link file, we call it a symbolic link file. So hard link file can be created with the help of an ln command. ln is a command to use it. Soft link can be created with the help of ln command with -s option. What is the fifth type of file? The fifth type of file is nothing but your pipe file, or we call it as a Fifo file. And this file can be created with the help of a mk Fifo command. And the sixth type of file is character device file, or block device file. And this can be created with the help of a mk node system call. And the seventh type of file is socket file. This can be created with the help of a mk sock command. So there are seven types of files are there in Linux or in Unix. Rajesh, do you have all these types of file in Windows? Yes. Maybe you might not have, but I am sure that you might have Fifo file or pipe file also. But I think most of these file types are there even in all the operating system. All operating system has these 7 different types of files. Apart from this, is there any other? No, sir. Only 7 types of files are there. Okay. Now, okay. So directory, you know, it's in blue color. Hard link. For example, here, I have a file. Yes, character device file, block device file. Yes. Ram Prasad, what is your question? Ram?
No question, just I.
Yes. Okay. Now, so guys, did anyone knew about this 7 types of files? Did you had a knowledge on this? Or you already knew this?
So I gone
Others-
through
Hard
some of
link,
the
soft
files.
link, and the directory.
Correct.
I gone through some of the these things.
Correct. So we have to understand about all the 7 different types of files. Maybe not very in detail, in a very high level, you have to understand. Because all these types of files we will be using in our scripting. A lot of time we'll be using, because we have to understand what type of file is it, whether it's a directory or not. So you might write a condition. If it is a directory, then I will do some operation. If it is not a directory, then I will not do operation. If the file is empty, I will do some operation. If the file is a non-empty, or it has some string, I will do some operation. Like that, you will use an if condition for just checking what is that file type. Based on that, you will take a decision what you have to do further. If the file is a directory, then only I will do an operation. Otherwise, I won't do. Like that, you will write an if condition. So at that time, you need to test it, what type of file it is. If the type of file is like that, then I will do some operation like that. Clear, sir? So it is very much mandatory. Now, for example, now I'll create a directory. Fine, very good, sir. Now what I will do that, I can check what type of file it is by using a file command. File command, you can check. Or else, suppose you have to do, I want to check what type of file it is. Then what happened, right? Along with the ls command, there is one option on the -l option, and say enter, right? You could see that it will display all the files and directory in a long listing. We say L means long listing. Now here it has given in the long listing. Can you see for the Pratap directory, it starts with a D character. Oh, it means that it is a directory. So I can say ls-l, pipe it to grep app of D. Display all the files which is starts with a D. See, it will display it. Suppose I create some more directories, mkdir, Ram Prasad, Mahesh, Suresh, who and all are the Kiran, right? And Rudraya. You have created so many directories actually. Can even say ls-l, pipe it to grep. Don't worry about this case. What is this cap, grep and all, will come across this. See, you can display all the files, all the directories with the beginning of the word D. Cap means begin with D. See, it will display like this. What is pipe, what is this and all, we'll discuss in some time. So now, what I'm trying to tell here that always a directories, you can either check the first character of the output of LSFNL. With that first character, you can judge what type of file it is. For example, here Alice and Bob, you could see that it is having dash. It means that this is null. This doesn't hold any value. So it means that it is a normal file. So like that actually. Okay. So let me do one thing. Let me remove the directory, some of the directories. I'll remove RMF. I will remove the Kiran, Mahesh, Ramprasad, Rudra, Suresh. I will remove all these directories. Okay, and I'll say ls. Let me keep this Pratap directory. So you have two files and one directory, right? Either with the file command, you can display what type of file it is, or else with the help of a ls-l and with the first character. Okay. Okay. Rajesh, is there any other way where we can display the file type? Yes, sir, we can display the file type. For example, if you do ls- with a capital F option, yeah. Whenever any directory is there, right, always it has a slash. It ends with a slash. Any file, if it ends with a slash, it means that it's a directory. You have to understand. So hyphen capital option also will tell you some information about, okay, what type of file it is. If it is a normal file, nothing is displayed actually. If it is an executable, yes, if it is an executable file, it will show you something like a star. Okay, for example, I'm changing a permission. So guys, don't worry. I'm introducing so many commands, but I will come across with all these commands one by one. Don't worry. Please don't worry. Just see what I'm doing. Chmod 775 Alice, enter, and ls-l. See, this has become an executable. And if I do an ls- with a capital F, see, it has shown star. Oh, it means that this file has an executable permission. Yes, Vaibhav.
Sir, why directory having a slash of it?
It's a directory. Pratap is a directory. Always a directory ends with a slash. It means that it will tell you that, okay, in this folder on this directory, there could be some other stuffs also. It could contain some more files, some more subdirectories also. That's the reason it should always end with a slash.
Yeah, thank you.
Okay, good. Now coming back here. So what is a hard link? See guys, whenever you are having a file, for example, here we are having a file by name Alice. Okay, let me do one thing. Let me revoke the permission. Chmod 64 and specify the file name. So I've revoked that execution permission. Okay, so I think my voice is echoing. Someone has logged in twice, I think, using the same link.
Sir, मैंने किया है. Actually, I don't voice issue on my laptop. That's why.
Or else, Vaibhav, you can mute yourself. Have you muted in both?
Yeah, I mute only.
Okay. Okay. Fine, that's fine. Yeah, coming back, hard link. So what is a hard link basically? See, here what happened, right? You have a file by name Alice file. So Alice is an empty file. I mean, it's a 0-byte file. It doesn't have anything. And we create this Alice file with the help of a touch command. Touch is one of the command in Linux, which is used to create a file, empty file or a 0-byte file. Right. And here what happened, right, guys? I don't have any content inside a file. It is an empty file. Suppose I want to write some text inside a file. I want to write it. So what I can use here, I can use a cat command, double greater than, specify the file name like that. So it'll ask me to enter some value. I'll say, hi, how are you? Bye. And at the end, I have to do Control D. Then what happened? Whatever the text you have given right here, right, that will get appended into this file. Now, if we do a cat of Alice, you see these 3 lines. So now the Alice file is not empty. That file has some content now. Now, if you execute the file command on Alice, it is no longer an empty file. It is an ASCII text file. Because earlier the file was empty. That's what when I execute the file command, it was showing as an empty. But if I do a file on Bob, it will say it's an empty file only. Suppose I want to write some text inside a file, I will use a cat command, double greater than buff. I take care something. Good night. And after that, I have to do a control D at the end. Now you see cat of Bob, it has these 3 lines. Now if I run a Bob file on Bob, you see it is an ASCII text file. Now it is not an empty file at all. It's an ASCII text file. Are you clear till here? Any doubts you have? Because I will be explaining some more thing so that I want to make sure that you all have understood here.
Yes, sir. Clear. All clear.
Guys, other people.
Sir, one small doubt. You need to press Control T, right? T for
Control D. D for donkey. Control D.
Okay.
Again, you'll ask me a question, sir, why you're doing control D? Don't worry, I will tell you about that later. Once I come to the signals part, right? What is signals, what are traps, right? I have to tell you some things on what are the shortcuts, what control D does, what control C does, what control Z does, what controls escape does actually. I have to tell so few of the things. So there I'll be explaining it actually.
Okay, thank you.
Right. Now, if you, sorry, who is the person who asked me? Sorry, what's your name, guy? Huh? Niranjan. Oh, sorry. Niranjan. Now Niranjan is very clever. Now Niranjan will not keep quiet. Rajesh is saying something, man. Signals in bash shell. He will not keep quiet. No. Signals of your bash shell. Sigterm, sigput. Okay, let me go to this document again. He is very intelligent now. He will see. Oh, Rajesh, something control C, control Y, oh, control Z. Oh, these are some kind of a signals it is getting generated. Oh, something there's a control D also. In this document, it is not there. So Rajesh may tell some extra thing about what is control D. Yes, I will tell something about extra after some time. Okay. So this is a very important, guys. The signals and traps are very much used even in scripting also. Like this. Traps. See, trap. You're trapping a signal actually. You're not allowing that signal to execute, or you're not allowing the signal to process. So that is nothing but through with the help of a traps. You can trap the signal. You're not allowed to execute its normal signal handler, right? You're not allowing it to execute the normal signal handler. So you want to trap it, right? You know, like for example, when a police, when a white police servant, when the single star or double star, right, the traffic police officer, right, what they'll do, they'll be standing in a side by the side of the road, right? They'll be having 2-3 constable. You know, some person, if he jumps the signals, right, all those 2-3 people come in front of him and they'll block his body, right? Something like the trap is something like that. You're trapping any kind of a process to be executed or any kind of a signal to be processed. You will be using a trap command at that time. Rajesh, where it is used? Something like, can you give an analogy? Can you give an example? Suppose, for example, you're running some application. The application is continuous learning and you want that application to run ever, or you want to run that application for longer time. Okay. Now you will say that, sir, Rajesh, if somebody comes and he interrupts my process, he interrupts the application to run. No, man, you can enable a trap within your script actually. Suppose somebody is doing control C. Somebody want to kill it. It'll never get killed at all. It'll never get trapped at all. It'll be keep executing. Oh, there you'll be using traps. You understood? Right? There is many things are there, right? Where you have to continuously execute your application, right? Without stopping. If somebody interrupts, you shouldn't allow it to be interrupted also. At that time, you use traps. See? The trap command in a bash executes a specific code in response to a given signal to a program. It traps a signal received by the program from the OS or the user and then executes a specific code provided by the programmer. It acts like a trigger in response to the signal. So when you're trapping it, you're not allowing it to do anything. It means that the normal execution of the application will be keep happening. It will never stop at all. So at that time, you can include the trap. This is very important in many advanced scripts. They use these traps. Make sure that the process or the application which is running, right, it shouldn't get killed at all. Right? You might, you want to monitor some system. You might run a process and go away tonight. Tomorrow morning, when you commit, you want to make sure that the process is still running. In between, if some other person comes and if you try to kill the process, what will happen? You have wasted your whole time, right? So that shouldn't happen, right? So you can enable trap within your script, showing that if somebody want to kill it, trap that signal and don't allow that signal to get executed. Trap that signal, disable that signal. We will write a script and show you, sir. about that. Clear?
Yes, sir.
Okay. So you will come across with some terminologies like signals, traps, exceptions, interrupts. These are some 4 kind of terminologies you will be always be hearing in Linux. Oh, some exception came in. Hey, some trap has come, or some signal has come, some exception has come, right? Or some interrupt has come, or some you might heard about a terminology segmentation violation has come. So this kind of terminologies you will be listening when you are working as a DevOps engineer, right? So that's how. So yesterday somebody asked me about a thread dump and heap dump. So what is a heap dump means? We will say that, hey, whenever there is any segmentation violation happens, then the heap will be, then you need to have a heap dump actually. So that heap dump will give the analysis to the developer that at which point of time when it was accessing some memory, the segmentation violation happens and the process was crashed or the process was abruptly get killed. That we call the segmentation violation. Segmentation violation memory. This is a very general terminology used even in Java in many languages, sir. Segmentation and violation with a Go language, segmentation violation in Python, segmentation violation in C, segmentation violation. You take any programming language, this is a very common word, which is segmentation violation. This segmentation violation will lead to the generation of the core file. With help of a core file, you can actually generate a heap dump and you can give that heap dump to the developer. That heap dump, what happened, right? The developer, when he analyzes, he will understand at which memory area this segmentation violation happens, so that for that reason, the process got killed or the process got terminated. Like that, he will get to know. So don't worry. I'm just telling you, we will see whether I will be able to cover those things or not at the end. Segmentation violation, heap dump, thread dump. I will generate a thread dump and I will show you the thread dump. I will run a simple Java program or the C program and I will generate a thread dump and I will show you that how threads dumps are getting generated. So what they will do now, the developer will take the thread dump or the heap dump. He has some debugging tool, GDB, KDB, some kind of a debugging tool will be there. They use that debugging tool, then they will analyze it actually, where it got failed, why the program got failed, like that. But we don't need to have all those information. So Rajesh, is it something like the shell script fails or something? Do you have to do debug? Yes, you have to do the debug, sir, of when the shell script fails actually. But that is not that much hard what we see in the programming and all. It's a very complicated thing. So you have to have many other debugging tools. Here in bash shell scripting, you don't need it actually. Even in Python also, we need it. I will tell you what is a debugging method which we use for doing whenever a Python script fails, right? How to do that, I will tell you now. I will tell you after some time, not now. Clear? Okay. So, sorry, we'll come back here. So what I'm trying to tell here, you have a hard link actually. Now what happened, right? For every file, so this is a file, cat is a file, Bob is a file. For every file, you can create a hard link actually. Hard link is nothing but another copy of a same file. Like for example, if I use a ln command, ln Alice space John, enter and say ls. Can you see John file has been created? John is a copy of the same Alice file. If you see cat Alice, it has this 3 content. Hi, how are you? Bye. If you see cat of John, it also has these 3 lines. Same lines are there. If you modify any one of the file, it will reflect even other also. So to modify a file, so I will be using a VI editor. VI is one of the editor which is used in Linux. I can open a VI command, VI Alice. I'm opening a file. Don't worry. I'm sorry. Again, I will come back to this. Now you're saying, Rajesh, you are telling I'll come back to this. When you're going to come back? We will come back very soon, sir. Within some time, I'll shortly start with the commands and I'll start with the VI editor also, because these are 2 important things which all the DevOps engineers have to know, because we are working in a Unix system or Linux system, right? We have to know the commands. We have to know even the editors also. Okay, so I'm using one of the editor known as a VI editor, and I open the VI editor, VI Alice. It'll open the file, and here what happened, I will try to append something. Bye, take care. Good night. Something. I mean, welcome. Anything. So I'm adding some text inside the file Alice, and I will save that file. Now, can you see that Does it has changed even the John file also? Yes, it has changed even the John file. Any one file you update, the other file also will get changed. So Rajesh, is John is a hard link for the Alice file? Yes, it's a hard link for the Alice file. Okay. Is John will get updated when Alice is getting updated? Yes, it get updated. If or whether if I change any kind of a content from the John, does it updates in Alice also? Yes, it will update. So let's see. I'll open John also. So I'll go to the end of the file. I'll go to insert mode. I will add some text inside a file. This I'm doing in a John. So can I do a cat of Alice now? Yes. So any one file you do, it will change. It will do even changes to the other file also. Now the question comes, sir, why we have to maintain this hard link? So hard link is another copy of a same file. It's another copy of a same file. Sometime what happened, mistakenly you have deleted the original file. You will have a hard link file. Still the file exists. You have not lost the data. Hence what happened in the industry, a lot of people will keep a hard link for that file. Who knows, somebody mistakenly deletes my original file. Still a hard link exists. Still you can recover a file actually. That's the reason what happened many times we'll keep a hard links actually. Okay. So there are three important points. Yes.
Does this hard link fit in the same place where the original file is available?
Yes, I'm coming to that point now. There are three important points which you need to tell if anyone asks you about the hard link. The first point is that hard link is always created for the file, not for the directory. Very important, sir. This is a must question which will be asked in interview. Many times it has been asked. How to recover the deleted file with a hard link? Yes. So for your question, Ram Prasad, there is a command by name debug-fs. By using a debug-fs, you can actually recover some of the deleted files. So there are some third-party tools are there, commands are there. Using that, even though you have removed a file, you can still recover back that file. Please Google it out. What is debug-fs? Okay. Now, so the first command is the first thing is that hard link is always created for the file, not for a directory. Suppose here, guys, can you see there's a directory by name Pratap? Pratap is a directory. When I create the Pratap directory, can I create a hard link for as an Arun directory? See, hard link is not allowed for a directory. It is only allowed for a normal file. That is first point. The second point is that whenever a hard link is created, new inode is not allocated. It means the same inode is used. And the third point is that hard link cannot be created across partitions. These are the three major points which you have to tell. If somebody asks you what is a hard link, you have to tell thing. Or what is the difference between hard link and the soft link, you need to tell it actually. Okay. Now the second point is that whenever a hard link is created, a new inode is not allocated. Now the question comes here, what is inode then? So inode, I stands for identification or index. So I'll draw it. This is a user space. Same old story. This is the kernel space. Okay, fine. Now here what happened? Some user has logged in. Okay, I will take the name as a Ram only, right? Ram or some. Can you give some of the name, guys? Which name I can use? I will use Balasa Krishna, Balkrishna, or I'll use Krishna as a name. Krishna has logged in actually. Krishna user, he has logged in, and you know that here you will get a shell actually, right? And this is, and you know that in between you will get a shell actually, correct? And here Here you will get a kernel. This we know, we have been hearing from last 7-8 hours. Same thing we have been hearing, right? Right. Now what happened? Krishna's user was logged in, and this is the shell. And which is the shell, guys? Bash shell. Bash is a default shell. We got it. Good, very good. Now what happened, right? Krishna, what he was going to do that, he want to create a file. Let him create an Alice file. What he will do, he will create a file with the help of a touch command. Touch Alice. He'll create a file. He has created a file, and when he does an ls command, he can see that Alice file has been created. So when he does like this ls command, he will know that, oh, okay, whatever file I want now, I have created this file. Oh, okay, Alice file exists. Okay, it has created it. But in Intel, how things are happening, how this file is getting created Alice. So as soon as Krishna is going to execute touch Alice, what the kernel will do, kernel will allocate the inode for that file Alice. It will create an inode. To create an inode. Inode stands for identification node, or index. We say I means identification or index. But to be very specific, we always term it as an index actually. Index. So this is something inode will get created. Okay, for every file, an inode will get created, guys. So for Alice, the inode, this inode will be attached. Okay, inode will be attached. So this inode will have a lot of information. This inode has a lot of information. What are the information which the inode internal holds? It holds information about who has created a file, who is the owner of the file. Who is the owner? Krishna is the owner, right? Oh, Krishna is the owner of the file. When was the file created? When? What's the timestamp? When was the file created? When is the file last modified? When is the file last changed? It also has the information about the inode number. Okay, every inode will have an inode number. It also has an information about the pointer to the data blocks or addresses to the data blocks. So these are some of the information where inodes maintain. And this information, guys, this information, whatever information you will find within the inode, we call this as a metadata. What we call? We call it as a metadata. If in some place, in some interview, if they ask you, Kiran or Ram or Balkrishna or anyone, hey, what is a metadata in Linux? Sir, metadata is not what that information which is there within inode knows that is metadata. Okay. So what is an inode then? Sir, whenever any new file is created by Linux, sir, always Linux kernel or the Linux operating system will assign a inode to a file. Okay. But why we need an inode? Sir, because that whenever the kernel or the operating system has to do an operation onto a file, it cannot do an operation to the file with the help of a name. It can only do an operation with the help of an inode only. So it means that does the file will be always attached with an inode? Yes, sir, it will be attached with the inode. Is it like same thing like how the shell is attached with the terminal? Yes, it is same thing like that. Always shell will always have an attached to the terminal name. Similarly, every file will be attached to an inode. Without an inode, the file will not exist at all. You cannot create a file which doesn't have an inode. Inode has to be there. So Rajesh, is this concept inode is there in Windows also? No, Windows doesn't have this concept like inode. Only Linux or the Unix flavor, right? Like you work on HPUX, Solaris operating system, IBM X, SUSE Linux, anywhere you use or anywhere you work, this concept of inode is always there. Okay. So what happened, right? For every file, an inode is there. So Rajesh, how to display an inode number? So here you have an Alice. If I do an ls with a -i and say Alice, you see it's an inode number. Guys, can you see this is the inode number? So Rajesh, is there any other commands are there where I can display inode number? Yes, sir. That command, add space Alice and say enter. You see an inode number here, 489318048931. I know. But apart from the inode number in the stat, right, it will give elaborate information. How many number of blocks have been given for that Alice file? What is a file size? What is a file name? What is an IO block? What are the number of hard links are there? Who is a user ID, group ID? What are all these permission, access permission, modify permission? So change permission, all these permissions, elaborate information about the file you can get with the stat command. This is a very, very important command, guys. You will be using this Alice stat command in every day frequently, most of the time. So guys, are you clear? So it means that if you go through this diagram, you understand that whenever any file is created, automatically the kernel has to assign an inode for that. And this inode in turn will have an inode number. Can you see here? I have written inode number. So whatever you're doing, ls-ie, when you're doing ls-ie, it is displaying the inode number. So you might ask, Rajesh, from where this inode number is getting displayed? So this inode number is getting displayed from the inode only, because this inode will maintain the inode number. Apart from all other information like who's the owner of the file, when was the file created, when was the last modified. Basically, this because the 3 timestamps. So whatever you're seeing, right? Access, modify, change. These are the 3 different timestamps we say. These are the 3 different timestamps, which is maintained by inode. Is it clear, guys? Are you finding interesting?
Yes, sir. Yeah, interesting.
Sir Solomon, sir, did you understood, sir? Okay. Suraj, did you understood, Suraj? Okay.
Sir, I missed that part actually. I just joined. My network was gone. So
Suraj, right?
yeah, Suraj.
Yes, Suraj. Should I repeat it again, all these things?
No, I'll watch the recorded session.
Okay, fine.
You can
So,
continue.
so it is there. Whenever you're creating a file, it is. So now here, coming back to a hard link. So what is the what I'm telling you here? Whenever a hard link is created, a new inode is not allocated. Same inode is used. So it means that Rajesh, when you created a hard link for this Alice file as a John file by using ln command, you know, right? I use this ln command. See, ln command, Alice and Bob, like that I use, right? Yeah, so here I run this command ln Alice John. So what I'm doing, if you ask me, Rajesh, what you're doing here, something, it's a reverse search, sir. How I'm doing reverse search means actually I'm using a control R. If I press a control R, it will take a reverse search. So if you have to identify, okay, I execute some commands some 2 hours or 5 hours back, right? You can do it. Oh, I know something I executed a command with ln. Here it will display everything. Whatever the commands you're doing, no, the reverse search will show you. Control R will show a reverse search. Clear, sir? Now, so if you're using ln command, ln Alice and John, like that, I already executed this command. So because of this command, what happened? The John file has got created. When I do a ls-i Alice, and when I do ls-i John, you see that, guys, it is pointing to the same inode. So that's the reason what I told very earlier, that John is another copy of the same file. Correct? John is another copy of them. So it means that here, if you go to the diagram, so Alice file is created, Alice file is pointed to the John file. Now what happened? Through the ln command, I created, through the ln command, ln command, I created a John file. John file got created. John is a hard link, but John is also pointing to the same inode only. It means that both the files are pointing to the same inode. So, Rajesh, it means that when I am removing a file, when I'm deleting a file, is it something I'm deallocating an inode? Is it something like I'm deleting an inode? Yes, it is a deleting inode. How to remove a file? You have to simply use rm command. Rm, and then if I say John, you are removing the file. You have removed the file. Now, as soon as you say rm command, remove the file, means you are actually deallocating that. It means that you are actually removing the link between the file name and the inode. What are the link? It is there, right? That link you're breaking up. That's what we use a rm command. So whenever removing a file, you will say, sir, it will remove the file. But what will happen? Sir, you are removing the link between the file and the inode. What are the file and inode is there, right? That link only you're breaking it up. So that is what you're doing rm command. Is it clear? Okay, good.
Yes, sir.
Okay, fine. So now, so same thing. So, and the third point for the hard link is that you cannot create a hard link across partitions. This is very important, sir, because sorry, I want to explain about the partitions and all. It is it will take some time. So what I will do, I will park this for some time now only. I will not go, but you can understand that if I'm having three partitions, assume that three partitions. In first partition number one, I'm having one file, and I want to create a hard link of that file into the next partition or the partition. It is not possible. Hard link will never get created across partitions at all. Okay. Opposite of hard link is a soft link, sir. You can create a soft link. The first point for the soft link is that you can create the soft link both for normal file as a directory and directory. Both you can create it. You can create a soft link or a symbolic link across the partitions. But here the important thing is that whenever you are creating a soft link, a new inode is allocated. And in one more thing, in the soft link file, if you are removing the parent file or original file, then you are losing the link. Okay, you are losing a link. So these are some 3 or 4 points for the soft link file. So here, if you come here, I have a Alice file. Now Alice file has this content. Okay, good. Now, if I want to create a soft link, I'll use a ln command. So what is a soft link? With ln with -s option, I have to use -s option. File is Alice file. Soft link file is something like John. The same file I'll create and say enter. And say ls. You see, you will get something like in a different color. No, the John. It is in a sign-in color. CYAN. Sign-in color is a light blue color. Is a sign-in color. This is a sign color. Sign color we say. Sign color. So here, John is in a John. Basically, it is a soft link file. Can I run a file command on John? Let's see. It is a symbolic link to this file. Okay, good. When I do a ls-l, enter, you see John file is having L. It is a soft link file. Okay. What about ls-capital F? Whenever any soft link will always start or it has. Yes, 1 second, sir. Let me complete. The soft link file will always have it always ends with the @ symbol. With this symbol, you will be able to understand. Oh, it is a soft link file. Yes, sir. Now you go ahead, sir.
What is the purpose of creating soft link, Rajesh?
Soft link is same thing like shortcuts what we use in Windows. You know, like you'll say, sir, you have a file, sir. Okay, like this. I want to go to the C drive. Under the C drive, I want to go to the program files. Under the program files, I want to go to the Google. Under the Google, I have to go to the Chrome. Under that, I have to go to the applications. Here you have this Chrome, sir. So whatever you have a Chrome now, here you have a Chrome. But do you think that everyone who want to access the Chrome, they will go to this path and run it like this? No. See what they did, right? They have took this and they've created a shortcut here. Actually, this whatever you're seeing here, sir, this is a shortcut of this, sir. When you are clicking here, actually it is calling this only under this path. Under this path, it is calling this only. So this is the original file. Or this is the original application. You have kept a soft link outside here in desktop for your easiness. You have kept it. This is we call it a shortcut in Windows. Similarly, shortcut whatever you want to create shortcut for a file or a directory in Linux is a soft link file.
Okay. Okay.
Clear, sir?
Yeah, clear.
Good.
Thank you.
Welcome, sir. Now, so now coming back here to a question, you can create a soft link for both normal file as a directory. That's all. I mean, I just create for the file. You can even try out for a directory. Okay. And the second point is that very important, guys. You can create a soft link across partition. This thing, as I said, I will come back after some point of time because I'm not yet explaining anything about partition and everything. Hard link, you cannot create a hard link across partition, but in a soft link, you can create a. That is a difference, I have to say. Whenever you're creating a soft link, a new inode is allocated. Can you see here? Can you come back here? Rajesh, can I run a stat command on Alice? Yes, it is showing me some inode number 48931805. Can I run a stats on John file? See, you see now the inode number has changed here. Oh, okay. Rajesh, it means that whenever you're creating a soft link file, a new inode is allocated for the soft link file. Okay, good. Very good. Good. So that's all. Now, Rajesh, can I access that Alice file through John? Yes, sir. That of John. See. So John is basically, if you see the symbol like this, if you do an LSFNL, if you see the symbol, John is actually a pointer to the Alice file. A pointer, it's just a pointer. Now you'll say, Rajesh, if I remove original file, RM Alice, enter, ls, can you see? Here, John has become, John is pointing to a file, but that file itself is not there. You have removed it. So it becomes a dangling pointer. So it is pointing to that file where that file doesn't exist at all. So we use the dangling pointer. If you have read the C programming, right? There is a book. There's a book by name Yashwant, the Understanding the C Pointers by Yashwant Kanitkar. If you have read in your engineering, right? He has explained about what is a dangling pointer. You will point to a file or you point to a memory address. That memory address doesn't exist at all. So that pointer will become a dangling pointer. Very important, sir. I mean, nobody asks you about all these things, but you might come across with what is called a dangling pointer. D-A-N-G-L-E. Dangling pointer in C. A dangling pointer occurs when a pointer to a variable goes out of the scope or when an object or variable memory gets deallocated. Clear, sir? Okay, good. So, are you finding this course to be more towards a programming thing or no, integrating the programming with other things? Sir? Are you finding out in that way? How you are finding this session? Or since from
So this session is finding deep understanding of Linux.
Yeah, deep understanding of Linux. Everything we are trying to understand it from the programming perspective, but not really that much required. But yes, something going on in the background, something you're understanding. Okay, it has a lot of programming everything. So that's the reason, guys, when the things were made so easy, it was being given a commands and everything to the front user, to the end user to break his head at all, how it is happening in the back end. Why I have to maintain, why I have to break my head. I want my command to be executed. When I execute the ls command enter, I want to get the output. That's all. I don't want to break my head what is going on back end and why I need to learn. Yes, that is correct only. As a DevOps, we need not to learn. But for understanding very in detail, when you're working on some more core levels, right? At that time, you might need all these knowledges. That's what I thought that initially I will take some time. Let it go 5, 6 hours, 8 hours, 10 hours. Let me go to some in a way where you can you can visualize everything practically. I want you all to visualize from very high level how things are happening in operating system or how things are happening in the shell level. You have to understand. Once we understood that, once we have set up that right, understanding other things will become very, very easy. We can go very fastly. So if we have spent a lot of time in understanding these things and all, no problem, no problem. We will give more time now. It's not like that I'll cut short the other things. No, shell scripting also for everything deeply will go, for every script will go very deeply. You yourself will tell me that, sir, Rajesh, you stop it. It's enough for us. You will tell like that. Because I will be executing some 20, 30 scripts I'll be executing, executing. You will get frustrated. You will say, sir, stop this, sir. Enough is enough. You'll say like that. 100% next week you'll say like that. Because so many things that I'll keep pushing so much, you'll say, what is there so much you have to learn? Yes, you have to learn. Once you start working on these things, no, sir, then what happens? You'll come across everything. You will be referring to the books, you'll be referring to the PDFs, you'll be asking somebody, you'll be Googling out, you'll be calling and asking me, what is this, Rajesh? What is that, Rajesh? So many things you'll be interacting with us. Then only your learning curve will start actually. Others, you will be standing there only. Where you're standing, you will be standing there only. You will not get to know many other things if you are not exploring the things actually. If you start exploring things, when you start writing scripts, right, then only all kind of trigger will happen in your mind. Because that you need to write an automation script. A lot of things you will come across with that. Clear, sir? So you will find,
Yes, sir.
yes, you will find specific DevOps engineers who are working on some nicey company. For example, you will see some people, DevOps engineer who are working for the AMD company. You know, AMD company is a processor chip making company. You will find a DevOps engineer who are working in the Intel company, inside Intel company, who are working along with the embedded professionals. You will find a DevOps engineer who is working in the Emulex company. Emulex, NetApp and all is a storage company, where they will be closely working with the storage devices, storage, everything. There also they have to do a lot of setup. So they need a DevOps engineer. So when you land up with that kind of a job, right, the expectation from you is that from the system level also you should have a very good knowledge. Right? I know the 80% of your market is grabbed with the application only, because you will see most of the companies are implementing application only, either through the Java or through the .NET, through the Node.js, through the JavaScript. There also you need Java. So there also you need DevOps engineer. So DevOps engineer will be dealing more onto the application perspective. So at that case, what happened? You might need only the commands. More than that, you don't need anything more than that. You will say, hey, can you automate this Vaibhav or Kiran? They'll say, okay, I'll automate it, man. Give me the commands, you'll say. Right? But when it comes to system level, okay, you need to go, when you are working as a DevOps engineer, other companies, like a very big company like Qualcomm company, right? One of my friends are working in Qualcomm company. Some of my friends are working in Apple company. Some of my friends are working as a DevOps in a Microsoft company. They are working very closely with the system level engineers also, because then they need to do a lot of automation tasks. They need all those things actually. Okay, now coming back here. So in the soft link file, if you're removing a parent or journal file, then you are using a link. That link we call the dangling pointer. Yes. Yes. This is the difference, sir. You have to tell this. If somebody asks in interview, what is a soft link and a hard link in Linux? What is the differences? Can you tell me the differences? They ask me, you have to narrate these 3 points, 3 to 4 points. Great. So this is a fourth type of file. Fifth type of file is a pipe file or a Fifo file or a Fifo file or a named pipe file, we say. So basically what happened, right? Whenever you're doing an inter-process communication between 2 different processes, whenever you're doing inter-process communication between 2 different processes, like this is a process A, this is the parent process, and this is a child process. Okay, there are 2 different processes are there. Something like a parent process or nothing but process A, and this is a process B. Whenever you are doing inter-process communication, you need a Fifo file. You need a Fifo file or you need a pipe file. So this is a pipe file. Pipe file. And the pipe file is basically, it is a unbuffered memory, we say. It is a buffered memory, not unbuffered, buffered memory. So whenever they want to do, so what the process A will do, process A is going to write some data inside this file. So you will write some data inside this file. Some data you're going to write like this. Some data or some content you're going to write like this. And this process B, it's going to read that from that file. And this file you call the Fifo file or the pipe file. Many times we will be using. And how to create a pipe file or the Fifo file? By using a mk Fifo command. mk Fifo command. Okay, like for example, if I want to show, can you see it? It will be very interesting for you. Here, what I'm doing here, mk, I think you have to use sudo command, sudo mk Fifo, my Fifo. The file name which I'm creating is a my Fifo. Enter, and then ls. Can you see there's something like a yellow color? It has created. Yeah, it's in yellow color, right? When I do a file of my Fifo, it's a named pipe or it's a Fifo file. So what Rajesh is saying that Fifo file is basically used for doing an inter-process communication between 2 different processes. Yes, sir. It's a 2 different processes you can use. Rajesh, this is a file, no? Yes, it's a file. It's a special file, sir. It's a special file. Okay. Now you will say that Rajesh, you are having this terminal. Okay. This is a terminal where you have a Fifo file. Let me do one thing. Let me do an echo command. Okay. Hello, everyone. I'm redirecting it to the Fifo file. What is the redirection operator? I will come across this later. Don't worry. Greater than sign redirection. You're redirecting this string to this Fifo file. You're writing something like here. You are writing some data into this file. Enter. Okay, sorry. I think I have to use sudo command. Let me switch to the root user. MK Fifo, my Fifo. Sorry. So you create a file here like this. Now, if you do a echo, hello everyone, redirect it to the my Fifo. You're redirecting. You have written the data. Suppose if you go to the other terminal here, go to other terminal. Here also let me switch to the root user. See, my Fifo is there. Can I say cat of less than my Fifo? Here you can read the data. See? From one terminal, you are actually pushing this content to a file. In the other terminal, you are reading it actually. So don't you see an inter-process communication, two different processes which are running at two different terminals? Can you map this? So in one terminal, you are writing a data to the file, in the other terminal you're reading. So it is a one-time activity because it is a buffered memory. Once the data is read by this process, the data will not be there at all. The data will never exist. So it is in a buffer memory, we say. So Rajesh, where we use this type of file? Yes, I will show an example in a script where we'll be using this type of file. And why we use the Fifo file also, I will tell you later. But did you understood the concept, guys?
Yes, sir.
Yes.
Good. Okay. Now the last, the character device file and the block device file, this will be used. So character device file and the block device file, these are the special types of files which are there. Okay. And if you have seen that when I executed ty, I'll exit out from here. When I execute tty command, it is showing me /dev/pts/1. So all the special device file, character device file or the block device files are there under this path. cd/enter. Can you see there's a dev directory is there? Under this dev directory, you will find all the character device file on the block device. Can you see tty1, tty2, tty3, tty4, tty5, tty5? These are all the terminals. Can you see something like a PTS? See, under the PTS, if you go inside the PTS, can you see 0, 1, 2, 1, 2, like that? See. Now, apart from this, can you see there is something known as a block device files? See, XVDA, XVDA. These are the block device files actually. This starts on the B, block device file. Similarly, for the character device file, LSFNL, IP to grep. Don't worry about all these things. I will come now in some time. So this is all the character device files. So some special types of files are there in the /dev directory. So those are used for communicating with the devices actually. Those are communicate with the devices. So for communicating with the devices, you need to create a character device file and the block device file. You can create with the help of a mknode command. So mknode command. So if you come over here and let me switch to the root user. I think in the other terminal, I'm already there in the root user. Yes. Now I'll use a mknode command. Mknode. Okay. I want to create a character device file. I'll say my file. The file name is my character. C 255 is a major number. 10 is a minor number. Enter and LSFNL. Can you see a file by name my has been created? It's a character device file. Similarly, mknode command. The file name is my block. Okay, you have to use B. Okay, 250 is a major number. 100 is a minor number. See, now you have created a my block file. Okay, Rajesh,
what does it mean by
yes.
100
Now, yes. Now the question comes, guys. It is little bit tricky to understand all these things because you might ask, sir, what is a major number and minor number? I think for you, don't worry about all these things. Just see, I'm running some command, mknode command using, and I'm using some mychar and see, and I'm saying 255 major number, 10 is a minor number. Okay, what happened? No, in Linux, what happened? Every device, you have a RAM device, you have a hard disk, you have some SCSI devices, you have some, you will have some what happened? You have some audio device, you have some sound devices, you have some graphic card device. There are so many devices are there. Each and every device, it will be registered to the operating system with the help of a major number actually. Please understand in that way. So I'm writing this note in some other notepad, or else do you want I can write it here. See, every device in Linux or in Windows, anywhere, sir, it doesn't matter, are registered by the operating system or by the kernel with some major number. With some major number. Now, to make you understand a still more better way, if I do an ls-l pipe it to grep. Guys, I'm under the dev directory only. See, if I do the pwd, I'm under the dev directory only. So dev, as I said, it is having all kind of special character device file and the block device file. Can you see there's sometimes a TTY0, TTY1, TTY10, 11, 12. So you have so many terminals are there which starts the TTY. Right? If I do ls-l pipe to grep cap of C character device file, can you see there are so many terminal files are there? TTY0, TTY1, TTY2. Can you see this column 4, 4, 4, 4, 4, 4, 4? See? Can you see the major number is same, but the minor number is different. TTY0, the major number is 4, minor number 0. TTY1, the major number is 4, minor number is 1. TTY10, the major number is 4, minor number is 10. See, you're having so many different terminals. Similarly, if you go to the if I execute TTY command, can you see /dev/pts1 is there? Okay, let me go into the pts directory, /dev/pts directory, and when I do an ls-l, can you see it is also character device file 1, 2, right? Can you see the major number 136, minor number 1. The major number is 136, minor number 2. It means that each and every device in Linux is actually registered with some kind of a major number. Now, suppose, for example, you are having a hard disk. Hard disk in my system now, if I execute the fdisk command, sudo or sudo df-h, disk free command, can you see it is a slash actually, but you want to see the what is this device is, you have to run sudo fdisk command. See, the hard disk for this is /dev xvda. See, /dev xvda1. Oh, this is a partition, but the disk type is xvda. Now, when I do, I'm already there in the /dev pts1. Okay, or I'll go back here. So when I do a ls-l pipe to grep cap of B, because it's a block device. Can you see xvda1? Can you see when I execute xvda1? Oh, what is this, Rajesh? This is a block device file, man. It is a hard disk. Okay. Now, can you see it's a block device? Major number 202, minor number 0. Major number 202, minor number 1. Oh man, there is something that these devices are registered with the operating system or the kernel with the help of a major number always. Now you go to the Google. What is the major number in Linux? You don't know something? The major number identifies a driver associated with the device. For example, /dev null, /dev 0 are both managed by the driver 1. So there are many things are there, so guys. You have to understand this. So this much is sufficient for you. I don't want to really elaborate more on this. So any device is identified by your system or by your kernel with some major number, and it could be a character device file or a block device file. So Rajesh, it means that Rajesh, my mouse is there, no? My mouse, whichever mouse. His mouse is also registered with the kernel. Yes, sir. Mouse is also registered with the keyboard. Yes, keyboard is also registered. The terminal, yeah, terminal is always registered with the kernel. Oh, it has a major number. Mouse also has a major number. What is a major number for mouse driver or for the mouse in Linux? See, these are the categories. It falls. The major number could be 147. For your mouse, and the minor number could be this one. Oh man, this is too much, sir. I don't want this much. You have to stop it here only, right? You understood, guys, what I'm saying here? So always every device is identified by the Linux by its major number. All the devices are registered in your kernel. All the devices are registered with the kernel with help of a major number. Without a major number, the device cannot be communicated at all by the kernel, by the operating system. And all these are there as a part of the device driver programming. So whatever you saw in the first day, right, the fourth subsystem of the kernel is a device management. Because the device management will have a device driver, and each and every device driver can communicate with the device. Yesterday I told you, right? Okay, right? So any doubts you have, guys? I know it was too much for some of you.
No doubt, sir.
But is it something you understood? I'm not expecting 100% to be known. Okay, but when you saw it, when I executed, when I searched for this, what is the major number in Linux? You will come across with /dev/null in your shell scripting. You will come across with /dev/0 in your shell scripting. These are some special types of devices. So Rajesh, can you go here, go back here? Okay, you are in a dev. You see there is something known as a null. So there is something as a null. NULL, where is null, sir? Can you see NULL, null? Yeah, it is there. Super, Rajesh. There is something like a 0, ZERO. Where is the 0? So /dev null, /dev full, /dev fuse. Okay, man, I understood now. So where is 0, /dev 0, ZERO? I'm not getting, sir.
It is in the last, sir. It is.
See, /dev 0. So ls-l /dev null. Oh, major number 1, minor number 3. Okay, something. ls-l /dev null /dev 0. So this is some of the special carrier device file. Where it is used, sir, I will tell you after some time. Now the question comes, what is this, Rajesh? You're always telling everything. I'll tell you after some time. Yes, sir, definitely I'll come across with all this time. So I'm just telling in a very high level. Now when I start going in a very deeper, no, I will explain about everything, sir. Still, we have not come across with the commands. I have not executed any command at all. Though I have told so many commands, but I will never say that I have come across commands. Commands I have to come. So till here, any doubts you have, sir?
No, sir. No doubts.
Good. Now,
these files are there, TTY, snapshot. These are yellow color, right? These files are pipe link files.
No, these are all character files. Sir, the pipe files will never be resided in the dev directory. Dev directory will only have two types of files. One is a character device and the block device. That's all. No other thing. It doesn't have, or it doesn't hold the Fifo file, or it even doesn't hold the socket file. No, these two files doesn't reside under the dev directory. Yes, now you ask me the question.
Watching that files, Fifo files also looks like same. So
no, Fifo file is used for doing an inter-process communication between one process to other process, where the character device file or a block device file is used for communicating with the device. Both are completely different. They are not same.
Okay, sir.
Clear, sir?
Yeah, clear, sir.
Very good.
Sir, one more doubt regarding
whatever he asked, so who was that person? Whatever he asked was very good actually, because he's trying to understand the differences between these two.
Sir.
Pratap, yeah, that is good only. Pratap, good. Yes, go ahead.
Sir, one more question regarding hard link and soft link. Soft link, we can create shortcuts. And in a hard link, we are for backup. I mean, what we say in case of
hard link, we say that whenever you want to keep a copy of the same file, you will always create a hard link for the file. Okay. Now what happened, right? You can create a hard link anywhere in any directory. Okay, like for example, in tomorrow's class, okay, for example, you will say, Rajesh, there's a hard link. Okay, let me remove the John file. I'll have a Bob file. Okay, so I will create a hard link for the Bob file as a Ravi. Ravi is a Bob file. Ravi is a hard link for the Bob file. It is there here. I'll do one thing. I will create a hard link for the Bob under the Pratap directory. I'll create a Bob file. Something like Praveen. Praveen is the Bob file. Now, when I do an ls-l, right? For this, you have created two hard links. You could see that one by default it has one hard link you have created as a Ravi, and one more Praveen you have created inside the Pratap actually. That's the reason it is showing here as a 3. So if I create one more, let me do one thing. Let me create one more directory. Pratap, I'll use your one name Vaibhav. I'll create a directory by name Vaibhav. Right? Vaibhav is the directory. Now I will say that ln, okay, Bob, okay, under the Vaibhav, I will create something like a Arun, something. Now when you do LSFNL, can you see here? It has increased here. So now in some automation tasks, you might be asked that please try to display how many number of hard links are there for that file and where and all that files are there, which are all the hard link files. You might not know, right? You might kept that hard link somewhere else, right? Here you have kept one of the hard link in Vaibhav directory, one of the hard link in Pratap directory, and one is already there by name Ravi, right? So you will be asked to write a script to find out how many number of hard links are there in the file and where and all the hard links file resides. So how you can find it out? By using a find command. There is one option is that using that you can all display the hard links of that particular file. So you have to write a script for that.
And more small doubts.
Yes, sir.
We created a hard link by Bob as Ravi, right? With that Ravi, we are not about to create another soft link with that Ravi, sir. Another hard link with that Ravi.
You can do it, sir.
We can do that. Okay.
Yeah. What's your name?
Pratap only, sir.
Pratap. LN Ravi. Sorry, LN Ravi. I'll not give Pratap. I'll create as a Kishore actually. Okay. You can create. See now, you see the hard links will be keep increasing, sir. Okay. Okay, fine. Now, the last point, the last type is a socket file. This is also very important, but we'll say it as a mksock. For some reason, they have deprecated this command, sir. You don't have this command mksock. Suppose if I switch to the root user, if I run a mksock command, let me check. This command is not there actually. Even in Ubuntu also, they have deprecated it. So they have they are not using this command now. Deprecated instance like they have removed it completely, sir. There's no package where you'll get a mksock. Sorry, man, what I'm doing. mksock command. MK command not found. So this happened like 7, 10, 12 years back. It was there. This command was there, but somehow they removed it. But even this type of file is also there actually. So, I mean, this is also one of the type of file, actually, socket file. Socket file is basically used for communication between two different processes running in a two different machine over the network, actually. So what it means that, for example, you have two different servers. I have two different servers. This is one server and this is another server. And both are in the internet, actually. And whenever this server A want to communicate with the server B, okay, they can communicate with the help of a socket file. They have to create a socket file like this. So this is nothing but your socket file. So only with the help of a socket file only, you can communicate with from one machine to other machine. So this is a socket file. I don't know how many people have observed that whenever you write, whenever you do a client server application program, whenever you are running, suppose you are remotely accessing from one server to other server. You are remotely accessing. You know, in this machine, no, under the temp directory, it will create one socket file actually. You might have observed or not. I don't know. Suppose you say that, Rajesh, I want to break this communication from this machine to this machine over the network. Please go to this path and remove that socket file. The connection will get lost. It means that the connection will get it will disconnect the connection. So whenever you are communicating from one machine to other machine over the network, then this system has to internally generate a socket file actually. Even this system also. So both the communication with this machine happens through a socket itself. And socket is a very important. And through the socket, by using some protocol or the rule, what happened, right? You communicate. What are the protocol? What is it? You will be using either the TCP/IP protocol or you'll be using a UDP protocol. And there are n number of protocols are there. So these are the major two protocols using which you can communicate between two different machines over the network or over the network. Clear? But within a single machine, within that same machine, if there are two different processes are there which they are running, and if you want to communicate within within this two different process within the same machine, it means that you have to use some inter-process communication mechanism, IPC we say. So like we use the pipe file, Fifo file, what we call Fifo file. You can even communicate the shared memory, right? You can even through message queues. There are different techniques are there where by using those techniques you can communicate between these two processes which resides in the same machine. But if you are communicating between two different processes, like for example here the server program is running, an application running in a Tomcat server. If this is running and here this is a client, if you want to communicate from here to here, from here to here you want to communicate, from here to here you want to communicate, means sir, you need a socket, sir. You need a socket. Internally, it takes care of communicate. The communication established happens with the help of a socket only. There's no other way. Without the socket, you can't communicate between two different machines. Whenever you're pinging from one machine to other machine, you ping, right? You're pinging. When you ping it, internally it uses a socket only to ping it actually. Through a socket interface only, the packet will be sent from one machine to other machine. And this server will receive it. And if the server wants to send any packet to this machine, it has to send a packet via that socket file only. So in a system or in the kernel, there is a network interface is there. Using that network interface only, the communication happens. 1 second, guys. Guys, is it clear, guys? Is this concept is clear?
Yes, sir.
Okay. Did you know about all these things?
Yes, sir. I know. I did socket programming. I was when I was embedded.
Okay. Thank you, Lauren, sir. Sure. Good, guys. So we have covered up to types of files. This took a very long time for us, but that's fine. Guys, with your permission, can I extend or we'll connect again at 5 o'clock? So what we are going to do at the evening time, I will take 2 hours class again at 5 o'clock IST, 5 to 7 p.m. IST. What would be my next agenda? I will tell you now. We will now what happened, guys? Now, with all of your permission, now I'm going to be little faster now. So what I'm going to do here, that the next is that I want to discuss about something about very quickly about the login shell and a non-login shell. Very important concept, non-login shell. This is the next important topic which we'll be covering, and we will be covering about the bash shell features. Bash shell features. We have to cover about the bash environment variables. We have to understand what do you mean by exporting in bash. Export is a simple command. Okay, and we need to start learning about the commands. Okay, so commands, basic commands like ls command, date command, who command, who am I command, calendar command. Then we will be getting into something like, for example, we need to understand about how to create a tar command, zip command, gzip command, unzip command, gzip command. So in Linux, there are two types of zippings are there. One is a bzip2, bzip actually we say 2, and other is a bzip2. Okay. And we have to learn about the tr command. We have to learn about the copy command, move command, or remove command, mkdir command. We know this everything. rmdir command, remove the directory. Okay, and we are using rm with a -f option, forcibly removing any file. Okay, and then we will be learning about the set command, awk command, paste command. Okay, and then about the about the TR. I think TR already have displayed it. And then like you have some more commands, like for example, like find command, grep command, right? And we have something with the test command.
The file permissions and
yes, chmod command, chown command, yes, chmod, chown.
rsync, sir.
Yeah, rsync, rsync, definitely. grp command, okay, ping command, ssh command, rsync command, yeah. Some of the commands. Now you will ask, sir, whenever I'm working on Linux, sir, how many commands at least minimum I should know? So according to my knowledge, at least you need to have a knowledge of 40 commands in your hands. This 40 number of commands should always be there on your tip of your hand when you're working on a system. Minimum, I'm saying. Now the question comes. Rajesh, how many commands are there actually in Linux? Actually, so there are more than 5,000 plus commands are there in Linux actually, but we cannot learn all the commands. It's not at all possible. We can only learn few commands. And how much maximum I can learn in my lifetime? You might hardly learn some 100 or 150 or 200, not more than that. In your lifetime, you might not learn more than 200 commands. You might learn hardly some 200 commands. So as and when you start working in the system, as and when you will come with a new requirement, something, you will tend to learn all new commands actually. Yes, of course. I mean, I missed it. One more thing. You have a man command. There is something apropos. There is some, yes, networking command also will run. Like for example, man command. Have you come across with the info command? Apropos command. Then netstat command, map command, traceroute command. What else? Ping command, and then ARP command.
Tail command, head command, top command.
Array, so many are there, yeah. Head command, tail command. What else?
DF.
DF command, fdisk command. Beautiful. Cut. Sir, the list is never ending.
About mount.
Mount command, unmount command. Very good, sir. Fdisk command. Have you heard of a command by name FSCK command? Filesystem program command, FCK. Whenever you want to format a disk, there is a command which is mkfs.ext3. File system you can do, or mkfs.ntfs. You see here, come back to the terminal. See, mkfs. See, can you see here? .minix, .fx, .ext4, .ext3. See, btrf. See, you will find so many commands like this. Like that, it is.
Sir, one more thing. To kill any process, one command is there. No, that also.
Thank you.
Something.
Kill command.
One important command.
Yeah,
Correct.
kill command is there. Yeah, kill command. strace is there. ptrace is there.
LSBLK.
LSBLK, good, very good. LSBLK, yeah, sir, there are n number of commands, sir. So every trainer, no trainer can cover everything, sir. It's very difficult. He will only try to concentrate on covering the maximum number of commands, very important commands which are used in a day-to-day activity.
Sir, actually, there is a in VA editor. There are few options are there.
Yeah.
How to change?
Yes.
VA editor change.
Yeah,
yes,
I will be covering
and line numbers, adding line numbers. And
yeah, sir. We will cover everything, sir. Don't worry, sir. VA editor, some important options.
Yes,
we will cover. Yes,
sir.
We will cover everything in the VA editor. Do you think that in the evening time can I cover this much? Not at all possible, sir. What we'll do? This, according to my knowledge, this will go up to 4 hours, sir. 4 hours. So today 2 hours. And the next, or in the weekdays, any one day, I will take 2 hours. We will be trying to cover everything, sir. So once this is completed, what I understand that now we will start learning about the shell scripting actually, because these are the building blocks. Whatever we learned now, basic shell scripting will start writing. So that will happen in the next week. If we are covering 2 sessions in this week on weekdays, right? Next week, early morning, right? We'll start up the scripting actually.
So maybe weekdays we can, sir, we can
Yes,
have
yes.
time. At night times 8 to 9 like that sometimes.
MKFS, Lawrence, MKFS, FSCK uses the file system check program. Correct. That is correct, sir. Right. 100%. So sometime what happened now, like for example, your file system have to go some kind of a file system check. Whenever you create a file system, okay, and there is a command is mke2fs file command is also there. See, mke2 mke2. See, this command is also there. Somebody was asking, sir, how to so there is something command is the debug-fs. See, debug-fs command. See, this command is also there. So many commands, sir. N number of commands, sir. You will get headache by going through all the commands. But make sure that you try to understand, learn maximum commands, whatever is required in your day-to-day activity. That is very much important, actually.
Like sudo
Yes. Now after this, there are many other important things are there. One is redirection operators, which I have to cover. Yes, redirection operators which I have to cover. One more is the pipes I have to cover. Pipelining I have to cover. Pipes, what are pipes and how the pipe works. This is also very important, which I have to cover. One more thing I was just recalling now. Just it slipped from my mind.
Sir, grep command, sir.
Grep, I think we have already mentioned here. No, grep command.
Okay.
Yeah, and after this, what I will do, like when I start the scripting, guys, okay, start a scripting, basic script I will do. In advanced scripting, I'm going to write a script only for sed and awk command. Sed and awk only, you need to concentrate more on this. Yes, one more thing very important which I missed is regular expressions and while characters used in Linux or in Unix. This is also very important. Regex expression. So after this, when we get into the basic scripting and all, right, there I'll be taking a sed programming, sed scripting actually. Okay, this will be for 45 minutes or 1 hour. Awk scripting, 1 hour, sir. I need 1 hour for this both. Okay, so and after that we will be involved in writing an advanced script. Advanced script, what I understand, what I feel like, I need an advanced script. Minimum I need around 4 to 5 hours, sir, to cover the advanced topics, advanced scripts. It means that it will take me around 2 sessions, more than 2 sessions, 2 hours, like around 5 hours. It will take me to complete the advanced scripts actually. Right? And then like many other advanced scripts which will be, it will take a time, sir. This will take a time, sir.
Will you cover conditional statements?
All, sir, all have to come, sir. So in the scripting, yes, sir. Without that, how I can cover, sir? Scripting, sir.
Yeah.
If condition,
Yeah.
if else condition, if else condition, is statement, right? Positional parameters. Let me note it down everything, sir. Yeah, positional parameters. And then what is happened? What is the sequence command? What we use in that? After that, we will use a looping statement. In the looping statement, what we have to learn is you have to learn for loop, while loop, and until loop. And after that, you will be learning about what is the functions, and you will be learning about the continue and break. Actually, you will be learning about the select statements. You'll be learning about the get-offs. You'll be learning about the signals and traps. You'll be learning about how to debug a script. This and all will be covered, sir. After this is covered, then we will get into the advanced script. For everything, all the things, I'll be showing one or two scripts. For looping, all this, for loop, 2 scripts, while loop, 2 scripts, until loop, 2 scripts. Functions, I will take around 30 minutes to complete it. For continue, 2 scripts. Break, 2 scripts. Select, 2 scripts. Get-offs, 2 scripts. Signals, traps, 2 scripts. Debugging, I will show you many things in debugging script. Like that, I will cover, sir. So you need to understand the syntax. You need to understand how to use, by using this, what are the conditions you have to use, and I will be explaining all those things, sir. So that you will understand the syntax. If you're doing any mistake in syntax, the script will never run. The script will fail. So you can understand, okay, there is some syntax, I'm doing a mistake actually. So 90% of the syntax is a space issue only in case of shell scripting. So space plays a very vital role. in your shell. And yeah, and also, yeah, one more thing I missed it here. I just remembered that user add command, user add or add user command. Okay, su command, sudo su command, sudo command. Yeah, this also have to cover. Okay, and very important configuration files. All major configuration files also have to touch. And one more important thing, that very important, after this, before getting shell scripting, I will have to say that how do you monitor the logs in Linux? All the logs, how to monitor all the logs in Linux. This is a very important. This will take me around 20 minutes to cover. Now you say, sir, how much time we need to cover the whole shell scripting advance? Do you think that we can cover everything in 20 hours or 25 hours? It needs minimum 40 hours to cover, sir. It is as same as you are giving a time for learning AWS. Suppose you are learning AWS cloud, you have to give minimum 60 hours of the time to learn the complete AWS concept. You need to minimum spend 50 hours in learning the Azure cloud, sir. So Linux is also so much actually. You can give more hours, sir. 50, 40, 50, but according to me, 40 is a ideal. It is a perfect time to give for everyone to learn the complete Linux actually. 40 hours is sufficient. So in that you'll be learning scripting, you'll be learning Linux. Yes, but it doesn't include any kind of other stuff. Like for example, we will not be covering anything on the server level. No. If you ask me, sir Rajesh, server level, do you configure the DNS server or NFS server? No. But I will be showing how to configure the FTP server, because in my shell script, I need to show how you have to create a FTP server, how you can automate it actually, everything in the FTP. That one script I'll be showing. For that, I have to show how to configure the FTP server. It is very simple, so it is not that simple. It's not that difficult. But in your, what I'm saying, that whoever is appearing for Red Hat certification or RHL certification, right, RXC or RSCE, right, there guys, you need to learn about a lot about the servers, like for example DNS server, NFS server, NIS server, SWIT server, SQUID, mail server is mostly postfix servers, postfix mail servers, right? DHCP server, right? NFS server, like that, Samba server. Okay, this is very important. And after that, there is a very important thing in the networking you have to do. You have to understand how to troubleshoot the network. So what I'm planning is that troubleshooting, basic troubleshooting. So after this advanced script completes, so let me remove these things. Okay. So after this we are not understanding. So I'm just putting in this dashes, which I'm not covering this. This is not required for us. If you still say that we want this, we will take a separate session, not now in this. So what I'll be doing now, after the end, right, I will be basic Linux troubleshooting sessions I will take actually. This will be probably for 2 hours. Okay, network troubleshooting. And at the end, what happened? At the end, what happened, right, guys? I'm going to take important interview question answers. So this will take me for 2 hours actually to cover everything. This would be our end of our session. Yes, Linux server patching. Yes. So what I will do that here. Yeah. After this, we will take a Linux server patching. Yeah, we'll take this. So thank you. Okay, guys.
Sir, sorry. Sir, actually, recently, while going one discussion, there is a conversation, and I understood there is a difference between sudo su and sudo su hyphen, right?
Correct. Yes.
That will route to the user home directory and normal present working directory, right?
Correct. Right. You're right, actually, 100%.
Okay,
right. So now your question. Now here, for example,
this might be useful to everyone. That's why I just.
Yeah, correct. See, now, for example, you are in this path. If you execute pwd /home CentOS, you are there. Right. Now, when I'm switching to the root user, if you do a sudo su root, actually, see, you are still under the same path. You will get into the same path. Now, for example, assume that I'm under this path. If I'm be under /user src directory, you're under src directory. You're under this path now. Okay. When you do a sudo su-root, see, whichever path you are there, no, it will take you to the same path. Suppose you are under the /user src. Suppose you do a sudo su hyphen. See, where you're taking to the /root directory. So when you're switching to the with the hyphen, right, by default it will take you to the home directory for this root itself. But when you're doing a sudo su root, right, if you're doing that, it will take you to the same path where you already were residing under the normal user. CentOS was there under /user. Even when you're switching to the root user, you are under this path itself. You're not moved to the /root. Did you understood?
Yes, sir. Yes, sir. Thank you.
Very good question, sir. This is very good.
Thank you.
Only some people will ask, because who has worked in system, he will ask me.
This is a silly question, seems like, but in interview it will play very.
No, it is not silly, sir. This is important only because why it is. I mean, how I can say means again in the script it will be used, sir. Actually.
Oh, okay, okay. Thank you.
Yeah.
Rajesh, what do you mean by tilde symbol and hash?
Tilde.
After the IP address, tilde symbol is there, no? Yeah.
Tilde.
Yeah.
Yeah. So now what happened, no, sir? This tilde will hold the information about the present working directory. When suppose you are having a pwd, so pwd it is /root actually. This holds the present working directory. Information of the present working directory. For example, if I'm going to cd to /home, okay, and I'm going CentOS. Can you see here? If I'm going cd to the /user src kernel, can you see here? This will hold the pwd current working directory information it holds. Okay, super. Understood?
Yeah.
Sir, now you understand that how deeply, sir, how deeply you have to involve in understanding everything, sir. You have to, you have to learn every way, whatever possible. Whatever you're asking is a very good question. But somebody who has explored everything, he only can able to answer you, sir. All the questions. Not everyone can answer all the questions, sir, because they might have not observed it properly. They have not worked effectively in a system, right? They might have worked, they might know, but they have not effectively worked. Those people cannot answer you, sir. A person who has really understood things in a very deeper way, who has explored many things, only that person can only help you or explain you in a proper way. Yes, sir.
Sorry, Rajesh. What is the difference between / and /root?
Yes. Because that is nothing but we need to start with the file system. So what we have to do that? I missed one more important thing. Login shell, non-login shell, bash features and all. Before this login, non-login shell, I have to explain about the file system. This is very important. This itself will take me around 20 to half an hour, 30 minutes it will take. So what we are going to do in the evening, we are going to start with the file system. I will cover your question over there. What is the difference between / and /root? Clear, sir?
Fine, Rajesh.
Okay. What is a partitions? What are partitions? You might have come across with many things like boot partition, root partition, something like what is MBR, master boot record. Something you might have come across with terminology known as tracks. Okay, you might have come across some as a what do you call segment. Okay, you might have come across, and you will come across with sometimes as a block actually. Like example, like 1K block, 1K block, 2K block, 4K block. You will come across with all these terminologies. You will come across this. These are all file system actually. Now, if you come over here, And if I see that you are having a file by name Bob. When you do a stat of Bob, you have seen this command earlier for displaying inode number you're doing. Can you see here something like IO block 104096, blocks 8 blocks, size, device identifier is this one, inode number of hard links 5, user ID, group ID, access permission. You are finding some interesting things here actually. These are all are related to the file system. All these concepts are related to the file system, sir. So one of the very core important component what you have to understand being a Linux user is a file system. Very important, because your stepping stone, your learning on the operating system or a system, everything together will start from the file system only. Now what happened? You will say, sir, I want to learn Windows, sir. How I can learn this? Sir, first try to understand what is this C drive. What is this C drive? What is this folder is all about, what each and every folder has, what intent this folder contains. When you're learning in this way, you are learning your whole Windows operating system only. Similarly, when I want to learn the Linux, always start learning Linux with the help of a file system. That is very important actually. File system. Clear, sir? I hope I think it's too much today. So we'll wind it up now. It's almost clear.
Thank you, sir.
Yes, sir.
Sir, I'm thankful to all of you that, in spite of that, you are sitting for so long time and you're asking question. I'm very thankful to all of you.
Sir, it's all because of you created so much interest in us.
Yeah, definitely. That's true.
Sir, now what happens, sir? Now you have to, I'll be sharing some PDFs, sir. Now you have to go and read the PDFs. Just give me 5 minutes.
So are you going to say this monitoring tools as well?
Sir, this I've already shared, sir. This drive. I think I've already shared this drive. Huh?
Monitoring tools, sir, like
yes, sir. ELK is there, Prometheus Grafana is there. Yes, Splunk is there. Yes, sir. No, I will take, sir. No, I will take it, sir. No worries. I will take it. I mean, I will take for my channel. For my this one channel. I will take it. Sir, I have given this drive to everyone, sir. Everyone have an access. If you go to the Linux, Advanced Linux Scripting, this is what is there in my channel. If you go to the PDFs, right, you have to start reading this PDF. One of the very important PDFs is a Steve Parker's PDF. This one, Mastering Unix Shell Scripting. Somebody asked you, Rajesh, where you are getting all the scripts from, how you are learning? Sir, I'm referring to these books only, sir. I'm referring to these books. I'm trying to learn about Doc. I have written something. This is a very good PDF, sir. Packed PDF actually. Okay, this you have to read it. So what are the things you have to read it? Like, for example, let me download this. Give me 5 minutes of time. I will show you this one. Pack. This is also very good, sir. Advanced Bash Shell Scripting by Mendel Kuber. This is also a very good book. And this is the Unix Shell Scripting Mastering by Michael K. Randall. This is also a very good book. See, I remember even the author's name also. How I remember? Because I read this book, sir. That's what I remember authors' names. People who doesn't have a habit of reading, they don't know anything, sir. They cannot read. That's the reason, sir. You could see that, for each and every company, right, you have a CEOs, right? For example, Apple has a CEO, like Microsoft has a CEO. Microsoft, the CEO, I think he's a Steve Barber, right? Still, sorry, Satya Nadella. These people are so much, they read so many books, in a year. One of the secrets of their success is that the people who read a lot of books, sir, they will get a lot of knowledge from the books actually. So, person who has an habit of reading, sir, he can only able to understand many things, sir. A person who doesn't have a habit of reading, sir, he cannot update himself, sir. This is the hard truth, actually. I'm telling you, people who don't have a habit of reading anything, so for them, everything will be difficult. He has to learn from some other person, listening to some other person. If you have a habit of reading, sir, you can explore yourself everything. You have a habit of reading, because when you have a habit of reading, sir, it will fine tune your mind. It will make you more thrust or more quest to understand many things if you start reading the books. If you don't have a habit of reading the books, you will feel bored. Oh, I can't read it. Then you will always be dependent upon some other person. Same thing, you would see that in industry. If you go to software in the industry anywhere, right, you could see that a lot of people will be dependent upon the technical lead only. Oh, sir, I lost technical lead. When I was in Lumen company, all my teammates, people were dependent upon me only. Oh, Rajesh will say something, Rajesh will do something, Rajesh will fix something. So why? Because that it's not like that. They can update themselves, but they don't want to update it. That is the main problem. What in the current, in the generation, it is happening that people are not spending a time on reading the books. That is what it is very that is what it is very difficult, or that is what it is happening, sir. They are dependent upon someone. So now, sir, just 2 minutes, then we'll do it. So when I'll upload all these things, or else you can download it. This is the book as well, Linux Shell Scripting by Vivek Guide. This is one of the very important, a very simple book, which you have to start learning from today only. See, Linux Shell Scripting tutorial by Vivek Guide. This fellow is a very nice guy, Vivek G Guide. Okay, and he has written a books, and he's having his own company, the Nextcraft. Actually, you could find a lot of articles written by Vivek Guide actually in the internet. Actually, you'll find. This is how you have to read, sir. See, he has covered all the basic things, sir. Awk revisited, said a real-time expression of the EX. See, essential utility for power user shell script, right? Advanced scripting, /dev null to send unwanted output. See, /dev null, local shell variables, IO reduction operators, functions. Oh, Rajesh, what are you saying? You read this book, sir? Yes, I read this book, sir. You know, I read this book, 272 pages, sir. In the year 2011, I read this complete PDF in 2 days, sir. 2 days I read it, sir. I spent around 7 to 8 or 10 or 12 hours to complete this whole PDF, sir. With practice, I'm saying. This one. So, you please read this book, sir. This is a very important book. You will come across with a lot of things like who developed the Linux. See, Linus Torvalds in 1991, he has developed it, and how to get a Linux. These are distribution. And then you come across how to install Linux. Okay, that is not required. So why Linux we use? Where and how Linux is used actually? Right? If you slowly come, see, user requests the shell will communicate the kernel, communicate to the hardware. See, can you see? The application will also communicate to the kernel, and kernel communicate to the hardware. See, what are the different subsystems are there? IO management, process management, device management, memory management, file management. See, can't you see here? What are the different types of shells? Yeah, I have to cover that also. Types of shells. Very important. And okay, very important. This is also one of the important types of shell. Okay, to change the shell, there is a command known as a chsh command. Where is the command? So change the shell. This is one of the commands, sir. So guys, I'm not making you scary to no. I'm not making you scary. I'm telling you that there are so many things are there to learn. My intention is to not make you scary and you feel like, okay, sir, what is this? So many things are there. Yes, there are so many things you have to understand. Okay. So, okay, guys. So please read this PDF, sir. It is my humble request to everyone. Once you read this book, I would request all of you to read this Steve Parker book, actually. And even this Ken Brochi book, actually. He's very good. This is a very good PDF. I mean, you will enjoy like anything by reading this book, sir. So at least read these 2 books, 2 books, that is sufficient. At least, see, if you see this Steve Parker book, it's a Vile publication, not this one. So this is the Michael K. Randall book. Yes, you can read it. Where is it, sir? Broach is there. Pack communication. Yeah, I think I didn't download it. Okay, you can read this also, sir. This is also very good PDF, sir. This is a very good PDF. You have to read from the very beginning. So what I would suggest you that don't read it completely. This fellow, sir, I personally connected with our Ganesh Nayak, sir. He is from Maharashtra. He's basically from Pune. I connected with him and I asked him actually like how he approaches. He's a big corporate trainer, sir, in Mumbai, and he gives a lot of training. And he's a lot of books are there. Ganesh Naik books are there even in Amazon also. And one of the latest book he has released is a Python book actually, and it's a very good book actually. And that person has shared his PDFs also on the Python actually to me. I requested him to share. No, he has shared the PDF to me actually. So see, getting started and working with the shell. See, working in a shell, learning basics command in a shell, or for shell script. Okay, you have to do. Okay, we'll be writing when not to use script, when to use a script. What are the various directories? See, so many things are there. Set user ID, group ID, umask. Yeah. I have to cover umask also. Umask set UID, SGID. Okay. Set user ID. So cron tab also have to. Oh my God, so many things are there. So cron job, cron is there, and one more something is at is there. That is also there. At. So join command, unique command, cut command, diff command. Oh my God, I missed so many things, sir. But I can't cover everything, sir. Please don't mind. I can't cover everything. Okay, which cover is very important. I'll cover only those commands only. But later you can explore everything. IO redirection, I have to cover everything. See, this and all you have to cover. You have to go through it, sir. Actually, see, this is the here operator actually. Here operator, and this is nothing but your debugging script with a -x, -v, and this is the file handling. So how do you file handle? Yeah, very important, sir. Which I missed it out here. Is after scripting or before scripting or in between the scripting somewhere, right? I'll be covering arrays also. Arrays, very important. Okay. Performing arithmetic operation. Yes. So this is a very good PDF, sir. I would recommend for all of you to read this complete books. This dialog box, which you're seeing here, right? Creating a dialog box. This they have deprecated in Linux. So there it is not used. There is no dialog box at all. If you see the command dialog, right here, dialog, DIALOG. See, this have been deprecated. They have removed it. There is no command with the name dialog box. So we will not be covering that one. Earlier I used to cover those things, but right now those are being obsolete. We don't do it actually. Have you heard, sir? Have you heard a scripting name by name TCLTK? Anyone have you heard about this TCLTK scripting? I worked in the scripting, sir.
No.
Yes, TCLTK scripting. Sir. All you can integrate TCLTK scripting. TCLTK is basically a graphical, sir. You'll get a dialog boxes. You'll get something like a widgets and everything through the TCLTK scripting. TCLTK scripting easily, TCLTK scripting easily integrated with your Shell or Perl or Python, sir. Anything. In some organization, like for example, one of my friend working in NetApp, he's using the TCLTK scripting. TCLTK scripting. Now nobody uses, sir, actually TCLTK. This is a tutorial, sir. You will learn everything. You can do, see, whatever whatever you can do it in shell scripting or Perl or Python, no, you can do through TCLTK also. Everything is very, very fancy looking here. So that's the reason what happened. A lot of people will even go to this also TCLTK. But now I see that most have been obsolete. The same thing, whatever you can do in TCLTK, people are not using now. They are using Python. That's the reason Python is highly recommended language, programming language, which has to be used actually. Whatever you can do shell scripting in Perl or in TCLTK, you can everything achieve in Python. So I would, at the end, I would say that please start leading or updating on Python. So that is required. Okay, guys, I think it's too much. I'll stop it here. And only 2 PDFs you have to read, guys. One is nothing but your Vivek Guide book, okay, which I told you. You have to finish it very fast. And other is nothing but your pack publication. You have to read. These 2 books you have to read. Whenever you're getting other time now, you can read it. This Broach book also can read it. This is a very good book. I have understood many concepts, very nicely. A tricky concept I have gone through this book, sir. I have learned many options. Many things I have learned from this book also. The network securities, shell securities and all I've learned from this book, sir, actually. Even though there are only 10 pages are there, but heavy informations have been given, sir. How you can actually create a MySQL server, MySQL database, how you can write a script where you can manage everything installation of the MySQL database, to creating a database, creating database table, monitoring everything. You can do through shell script also, sir. See, those things and all, you can manage everything. So at the end, in advanced script, actually, one of the script I will show you, like how to write a script to install the MySQL database, install the MySQL client, and creating a database table. Okay, and communicate database. I will write a simple script, sir. It will be hardly like 10 or 15 lines of code will be there. I will write and I will show you that. So that will be a very interesting stuff for you. Is it clear, guys?
Yes, sir.
Yes, Rajesh.
Yeah. Thank you, sir. Thank you all. We'll stop it and we'll all meet again at 5 o'clock.
Yes, sure, sir. Thank you, sir.
Thank you. Thank you, sir. Bye. Let me stop the recording.
Bye.
Bye.
Sir, one more thing I have to ask.